Hello there and welcome to Just About Earth, where curiosity settles in beside you and science takes its time, letting each idea unfold at a pace that feels unhurried. Tonight we're wandering into a question that has lived quietly at the edge of imagination for a very long time. It's the kind of question people tend to ask only late at night, or during long walks, or in those small moments when the mind starts drifting toward the bigger picture. A question about the ground beneath you, about the layers hidden below stone and soil and history. A question that may seem simple at first, but grows the longer you hold it. What if humanity isn't Earth's first intelligent species? It sounds bold. It sounds like the start of a story someone might tell around a campfire, the sort that begins with a whisper and ends with someone glancing over their shoulder. But when you look at the age of our planet and the scale of time it contains, the idea becomes less strange and more like a possibility worth exploring. Earth is 4.5 billion years old. Human civilization, even if we stretch the definition generously, is a blink by comparison. Almost everything that has ever lived, built, changed and vanished existed long before us. And so the question isn't just imaginative, it's reasonable enough to pause over for a while. Before we wander too far, I'd love to know something simple. Where are you listening from tonight? And what does it feel like where you are right now? Maybe you're winding down after a busy day. Maybe you're easing into bed. Maybe you're sitting somewhere quiet, letting your thoughts slow just enough for bigger ideas to settle. If you find this kind of gentle exploration soothing or interesting, or simply a comfortable way to drift into rest, I'd be so grateful if you left a like or subscribed. It helps this little corner of calm find others who might also need a slow, steady voice to guide them into sleep. So settle in. Let the day soften a little. Let whatever you were thinking about before set itself gently to the side. Because this question, the one about whether we are truly the first thinking, tool-making, world-shaping species Earth has hosted, takes patience. It doesn't need big leaps. It just needs time to open. And the best place to begin is by taking a long, quiet look at the Earth beneath us. When you think about the history of life on this planet, it's easy to picture a neat timeline in your mind. Dinosaurs here, mammals there, humans appearing just before the present day. But real history isn't neat. It's scattered, layered, rearranged, swallowed by oceans, lifted by mountains, erased by erosion, melted by heat, and sometimes crushed beyond recognition. Entire periods of Earth past are missing, not because nothing happened during them, but because time is relentless in the way it repaves the surface. If a species had risen to intelligence millions or even hundreds of millions of years ago, how would we know? What would survive long enough to find? Our most durable human structures crumble in a few thousand years. Metals corrode, plastics break down, roads collapse. Even skyscrapers wouldn't last long in geological time. Within millions of years, everything turns to dust or sediment or molten rock. So the first step in considering whether another intelligent species might have come before us is accepting that the fossil record and the archaeological record are both tiny windows, narrow and fragile. They show us only what happened to survive under specific conditions that are rare. This doesn't mean earlier intelligent life did exist. It also doesn't mean it didn't. It simply means the door is not as tightly closed as we sometimes imagine. And once you allow yourself to look through that unlocked door, the world beneath your feet feels older, wider, and a little more mysterious. The Earth has undergone repeated cycles of catastrophe and renewal. Entire continents have sunk beneath the oceans. Vast layers of rock have been folded and broken. Ice ages have scraped landscapes down to the bedrock. Volcanoes have covered regions with lava thick enough to bury worlds. If a species had developed language, tools, societies, or even something like technology long before humans came along, its story might have been wiped clean more than once. Even now, we rarely find complete traces of ancient animals. We often find fragments, pieces of teeth, bits of skeletons, faint patterns pressed into stone. For every fossil we discover, there are countless species that left no trace at all. Life is abundant, fossils are rare, and civilizations, if they ever existed before ours, would be rarer still. Imagine for a moment that you were to build a city. You work hard on it. You stack stones. You lay paths. You construct structures, some tall and some small. Now imagine leaving that city alone for 100,000 years. Nature takes it back. Trees split the walls. Rivers change course. Soil covers everything. Now stretch that time to 1,000,000 years, then 10 million. Eventually the city is gone. Not damaged, not abandoned, but erased. Not by hands or fire or storms, but by the normal rhythm of the planet. Most of Earth's surface is younger than you might think. The ocean floor, for example, is constantly renewed. Almost all of it is less than 200 million years old. Anything older has been pulled into the mantle and melted away. If intelligent life had arisen in a marine environment so long ago, every trace could be gone by now. Land doesn't last forever through geological time either. Mountains rise and fall. Rivers break down bedrock. Continents collide. Landscapes are recycled over and over. Our entire species, with all its structures and artifacts, would fit into the thinnest outer layer of geological history, a layer that can vanish in the blink of a geological eye. This doesn't mean earlier civilizations were likely. It only means the planet is old enough, dynamic enough, and unpredictable enough that the possibility is not unreasonable. And that's what makes the idea worth exploring slowly. It gives us a chance to consider not only what might have happened in deep time, but also how we fit into a world that has existed far longer than our memories can reach. One of the first things to consider is the sheer variety of life. Intelligence is not a straight line from simple to complex. It appears in bursts. It emerges in different forms. It's shaped by environments and pressures and opportunities. It could arise on land, in water, underground, or even in ways we haven't imagined. When we think of intelligence before humans, our minds often leap to pictures of creatures walking upright or building with hands like ours. But intelligence doesn't require hands. It doesn't require fire. It doesn't require cities. It requires only the right combination of sensory ability, problem-solving, communication, and long-term survival. On Earth today, we see glimpses of intelligence that developed independently. Octopuses solve problems and use tools. Crows craft hooks and remember faces. Elephants communicate over long distances and show signs of mourning. Dolphins recognize themselves, form strategies, and teach behavior across generations. These are not precursors to us. They are parallel examples that show intelligence isn't a single path. If we vanish tomorrow, they might be the seeds of something new millions of years from now. But the question we're holding tonight looks backward instead of forward. Could something like that have already happened long before us? Could a species have risen to awareness, navigated its environment with increasing skill, developed social structures, passed knowledge across generations, and then disappeared entirely, leaving no obvious trace? Some scientists call this the Silurian hypothesis, named after a fictional species, though the idea itself is scientific in structure. It asks whether it is possible to detect a civilization in the deep geological record if its traces have been erased by time, not because they expect one existed, but because thinking about the question helps clarify what marks civilizations leave behind and how those marks fade. One clue might be unusual chemical signatures. Our own civilization leaves behind synthetic compounds, plastics, metals, radioactive isotopes, and changes in atmospheric gases. Over millions of years, plastics would break down, metals would corrode, isotopes would decay. But some chemical fingerprints might linger faintly, not as objects but as deviations in the geological layers. Still, even these could blend into natural processes or be erased by heat and pressure. Another potential clue could be mass extinctions tied to unusual causes, but Earth has had many extinctions, most of which had natural origins like volcanic events or asteroid impacts. If an earlier civilization had caused environmental damage, it would be difficult to distinguish from other natural disruptions unless something very specific survived. So far, no definitive evidence exists. But absence of evidence, especially in a geological record so thin and fragmented, does not guarantee absence of possibility. Earth has room in its timeline for many stories, including ones that might have risen and ended long before the first mammals climbed down from the trees. Thinking about this can reshape how we see ourselves, not as the inevitable result of evolution, but as one possible outcome among many. Our presence here is recent, fragile, and surprisingly small in the context of deep time, and that perspective, rather than making us insignificant, can make our existence feel more precious. It reminds us that intelligence is rare enough to cherish each moment it appears. Imagining an earlier intelligent species is not about believing one must have existed. It's about recognizing that Earth's history is long enough and complex enough that certainty is often beyond our reach. It's about understanding that our world holds secrets, not because they are hidden, but because time has layers we cannot peel back completely. And as we continue wandering through this idea, we can let the scale of it slow us, let it stretch the mind gently, let it make the present moment feel a little softer. Because this story isn't about final answers. It's about the path through a question that connects ancient Earth to our modern lives, creating a sense of quiet continuity across the ages. From here, there are many directions to explore. The ancient Earth beneath us holds more than rock and sediment. It holds the possibility of forgotten worlds, possible rises and falls, and the long, gentle patience of a planet that has seen far more than we can imagine. When you start thinking about how old the ground beneath you really is, the mind needs a moment to adjust. Most of us carry a mental picture of Earth that feels familiar, stable, and mostly unchanged. We imagine mountains staying where they are, continents holding steady, oceans remaining exactly where we expect to find them. But the Earth has never been a still place. It shifts, breaks, reforms, sinks, rises, and cycles through transformations at a pace too slow for a single human lifetime to register. If you could watch millions of years unfold in the span of a few minutes, the planet would look nothing like the calm surface we take for granted. It would move like something alive, always reshaping itself, always rewriting its surface. Thinking about an ancient Earth that existed long before us means letting go of this sense of solidity. The ground hasn't always been here in the form you see it today. Much of it didn't exist during earlier ages. What you're standing on now might have been deep beneath the ocean at one point, or part of a volcanic plain, or nowhere at all because the land had not yet formed. Entire continents have split into pieces and collided again. Oceans that once covered enormous regions have vanished completely. And on the timescale we're talking about, the surface is a temporary veneer, not a permanent stage. This matters when you ask whether life could have risen to intelligence long before humans. Because even if something extraordinary once walked, swam, or lived on ancient land, the land itself may not have survived. If the landscape didn't endure, neither would the things built on top of it. To imagine what might be buried beneath our feet, you have to picture not just fossils and minerals, but whole worlds that existed before the continents took the shapes they have today. The earliest chapters of Earth's story are almost entirely erased. The first billion years are sometimes called the planet's dark age, not because nothing happened, but because so little information remains. The crust was unstable, impacts were common, oceans were still forming and evaporating again. Heat from within kept the surface in constant motion. Any hint of early life, let alone anything advanced, would have been lost to the churn of molten rock. Even the oldest rocks we've found are not from the dawn of time, but from a point long after the planet had begun to cool. After that, things settled a bit, but not enough to preserve everything. Nearly all traces of the earliest organisms have vanished except for chemical hints and occasional microfossils. If simple forms struggled to leave their mark, something more complex would have had an even harder time. Standing at the surface today, you see what survived, not what existed. That difference is important. Imagine peeling away the layers of the Earth very slowly, one after another. At first you might find scattered artifacts from human civilizations, then bones of animals we recognise, then older creatures, ancient forests turned to coal, shells packed into limestone. Keep going deeper and the fossils change, growing stranger and more unfamiliar. Soon you reach periods where only a few hard-bodied organisms appear. Then farther down still, the record begins to blur. Layers of rock fold upon each other, melted or compressed until the original structures disappear. Go deep enough, and you reach rock that long ago passed through temperatures high enough to wipe away any trace of life. And that's assuming the rocks remained in place. Many didn't. Much of Earth's crust has been drawn into the mantle and recycled. The surface you see now is not the surface that existed hundreds of millions of years ago. It is the outcome of constant renewal. Ocean floors spread outward like conveyor belts and disappear at subduction zones. Mountain ranges erode until they flatten. Islands grow, split, sink and vanish. What remains from earlier ages is scattered and incomplete. So when you think about whether intelligent life could have existed before humans, the question becomes less about what we found, and more about what the planet has allowed to survive. Most of Earth's story has been lost not because it was hidden, but because it was overwritten by geological processes that continue every day. Our species arrived recently enough that the world still holds the imprint of our presence. But go back a few million years and even large structures would be gone. Extend that to tens of millions of years, and the odds of finding evidence drop close to zero. That perspective helps explain why even well-preserved fossils are rare. Fossilization requires very specific conditions. An organism must be buried quickly, usually in sediment or ash. It must avoid scavengers, decay, and disturbance. Minerals must replace or encase the remains. Geological pressure must not destroy them. And even if all that happens, the fossil still has to be discovered by someone able to recognize it. The result is a record made of lucky events. Now imagine trying to find the remains of an intelligent species that lived, thrived, and vanished hundreds of millions of years ago. Their tools would decay. Their shelters would collapse. Their cities would crumble. Metals would oxidize. Organic materials would decompose. Even if they left behind objects of extraordinary durability, those objects would have to survive long enough to be incorporated into the right layers in the right conditions and then reappear at the surface without being destroyed by heat or pressure. It's not impossible, but it's unlikely enough that the absence of artifacts doesn't tell us much. The Earth is full of gaps. Whole eras are missing. Sediment layers that should exist don't. Rocks from certain times are found in only a few locations or not at all. Each gap is like a blank page in a book where the story continues but the text is gone. Some pages were never written, others were erased. When geologists look at a cliff face or a canyon wall, they see this pattern everywhere. Layers that should connect sometimes don't. A smooth line of rock may hide a sudden jump in time where millions of years are missing. Those missing layers are where imagination fits most easily. Not because we want to fill them with speculation, but because the reality is that anything could have happened during those intervals. Life could have flourished, changed, evolved, or disappeared, and we would never know. That doesn't mean earlier intelligent species existed. It simply means the possibility isn't closed by the data we have. When people imagine ancient intelligent species, they often picture something humanoid or something large and imposing. But intelligence doesn't require a human shape. It doesn't require hands or fire or tools made from metal. It could arise in bodies suited for climbing trees or swimming in oceans or living in underground systems. If a species developed intelligence without needing to manipulate objects, the traces of their existence would be even harder to detect. Consider animals alive today that show complex behaviors without leaving physical traces. Dolphins use strategies, communicate across distances, and cooperate in ways that look like coordinated plans, yet they leave little behind for anyone to find. Elephants remember paths and water sources across decades, but leave no written records. Octopuses open containers, escape enclosures, and solve puzzles, yet the only trace they might leave in the distant future is a shell from a species that has one. Intelligence doesn't require permanence. The Earth holds so many environments that could have supported forms of intelligence we wouldn't immediately recognise. Ancient coastlines, long since submerged or transformed, might once have been home to creatures with the capacity for learning and coordination. Forests now turned to coal may have sheltered species with a growing awareness of their surroundings. Grasslands we no longer see might once have supported animals whose communication systems never left a fossil trace. And yet, despite all this, it's not the evidence we're missing that draws attention, but the sheer amount of time available. The Earth is old enough for countless cycles of rise and fall. The dinosaurs ruled for over 150 million years. Mammals have been around for tens of millions. Humans, depending on how you define us, emerged only a few 100,000 years ago. Our entire story fits into a tiny space at the end of a very long timeline. When you broaden your view to the entire history of life, humans are not the expected endpoint. We are an outlier, a newly arrived species standing on ground shaped by countless events we never witnessed. If earlier intelligent life had existed, their era might have been just another cycle in Earth's long pattern of creation and loss. Their rise might have come and gone during a time when the continents were arranged differently. They might have lived on land that no longer exists. Their world could have been destroyed by natural disaster, leaving only subtle hints that blend into the geological background. Or they might have vanished gradually, leaving nothing behind but altered ecosystems that eventually changed again. Thinking about these possibilities doesn't require imagination running wild. It only requires recognizing how little of Earth's past we can access. The stones and sediment beneath us hold memories, but most of those memories are fragmented. They show glimpses of life rather than the full story. They preserve moments, not the entire narrative. What makes this interesting is not the idea of uncovering some hidden ancient civilization. It's the realization that our relationship with Earth is shaped by the tiny window of time we occupy. We see ourselves as the first beings to ask questions about the planet, but we don't know whether that's true. We see ourselves as the first species capable of shaping environments on a global scale, but we can't say with certainty that nothing similar ever happened before. The deeper you look into Earth's history, the more you start noticing how much has already been erased. The ocean floor that existed 300 million years ago is completely gone. The surface that supported the earliest forests has crumbled. Mountain ranges from ancient times have been reduced to pebbles. Entire environments have vanished without a trace. The Earth is a place where loss is normal, and survival of evidence is rare. And yet, even with so much missing, the planet still offers enough clues to tell us that life has been experimenting with countless forms for billions of years. Intelligence might be one of those experiments. It might not be unique to humans. It might have appeared, disappeared, and reappeared across different eras. Or humans may be the first to reach this level of complexity. We simply don't know. As you keep exploring this thought, you may find your mind drifting to the surface again, wondering how much of what we have built will endure. Our presence on the planet feels significant to us, but in the larger story of Earth, it is still a new chapter. When you begin thinking about how intelligence appears on a planet, it's easy to picture it as a single event, something that happens once and then moves steadily in one direction. Human history reinforces this idea because our own rise seems so dramatic and recent. But evolution doesn't follow a straight line. It moves in many directions at once, shaped by chance, environment, opportunity, and pressures that shift constantly. When you step back and look at the full span of Earth's history, the emergence of intelligence doesn't feel like a rare spark that flickered once. It feels more like something that could happen many times under the right conditions. Life has been experimenting since the moment it began. Even simple organisms show signs of problem-solving, adaptation, and learning. The early Earth was full of challenges, from shifting climates to unstable environments, and every living thing had to respond in ways that helped it survive. Over time, these responses became more complex. senses sharpened, nervous systems expanded, bodies adapted to new habitats. Communication appeared in many forms. These weren't steps toward humans. They were steps toward whatever worked for each species at that moment. When you look at intelligence this way, it becomes less about achieving something and more about extending the ability to navigate the world. Different animals show different pieces of intelligence today. Some communicate with nuance, some solve puzzles, some plan for the future, some work together in structured ways. None of these abilities belong solely to us, and they suggest that the potential for intelligence lies in many branches of the evolutionary tree, not just the one that eventually led to humans. If you imagine Earth long before our species existed, the possibilities widen. Life wasn't confined to one path. It spread into oceans, swamps, forests, plains, shallow seas, deep trenches, small islands, and vast continents. In each place, different creatures faced different pressures. Some evolved speed, some developed camouflage, some relied on strength. Others grew more aware of their surroundings. Intelligence isn't a destination, but a tool. And tools arise whenever they provide an advantage. Consider animals alive today whose intelligence developed separately from ours. Octopuses evolved with completely different bodies, senses, and lifestyles, yet they show remarkable problem-solving abilities. They can open containers, navigate mazes, escape enclosures, and manipulate objects with coordinated precision. Their ancestors diverge from the lineage that led to humans hundreds of millions of years ago. Their minds evolved in an entirely different environment, one without fire, without land, and without the things we associate with technological progress. Yet they reached a level of awareness that feels familiar in some ways. Crows and other corvids show another example. They make tools, recognize faces, and demonstrate an understanding of cause and effect. Their intelligence evolved from ancestors nothing like ours. And then there are elephants, with their social complexity and remarkable memories. Dolphins communicate in patterns we are still trying to interpret. Bees perform dances that convey information about distance and direction. These examples don't tell us that these species are on their way to building cities or machines. They tell us that intelligence is not a single path. It's an option nature can explore whenever it suits the environment. If intelligence can arise independently in so many modern species, it becomes easier to imagine how many times it might have emerged in the distant past. Some might have developed forms of intelligence that didn't rely on tools or structures. Others might have created objects or systems that left no trace for us to find. Some might have reached a level of complexity we can barely imagine, only to be erased by time, by disaster, or by the slow reshaping of Earth's surface. The question isn't just whether intelligence could appear more than once. It's how often it might have emerged without leaving the kind of evidence we would recognize. When people think about past intelligent species, they often imagine things similar to humans. But intelligence is broader than that. It could look like animals capable of planning, coordinating, and communicating in advanced ways. It could involve creatures that built structures out of materials that decompose quickly. It could belong to species that lived in environments where preservation is extremely rare. Most fossils come from areas where sediment collects. Bones, shells, and hard structures survive best when buried quickly. But many environments where intelligent behavior might arise, dense forests, wetlands, coastal areas, or shallow waters, are places where remains break down fast. Even today, animals living in those regions leave few long-term traces. If an intelligent species had evolved in a rainforest millions of years ago, it could have lived and thrived without leaving anything behind except occasional fragments that never fossilized. A species that lived along a coastline during a time when sea levels were different might now be buried under water or lost beneath layers of newer sediment. And then there's the issue of duration. Humans went from stone tools to global communication in just a few thousand years. If another intelligent species had existed for a brief period, say tens of thousands or even a few million years, That span would be almost invisible in the geological record unless conditions were perfect for preservation. Many species come and go without leaving much evidence. Intelligence doesn't guarantee visibility. Something else to consider is the size of the population. Humans are widespread, but earlier intelligent species might have been few in number or confined to limited regions. They might have lacked the environmental impact that makes our presence so obvious. If their tools were made of materials that decayed quickly, nothing would remain. If they built in environments prone to erosion, those structures would vanish. Even if they reached a high level of complexity, their artifacts could easily end up being mistaken for natural features or simply lost in the vastness of geological time. Evolution also tends to cycle through ideas. Traits appear, disappear, and reappear depending on what helps a species survive. There's no guarantee that intelligence will always lead to technology, nor that technology will always leave recognizable traces. A species might develop sophisticated communication, but no interest in constructing objects. Another might build shelters from biodegradable materials. Another could adapt to aquatic environments where nothing remains to be found. At the same time, we shouldn't underestimate what early forms of intelligence might have achieved. Some species today, despite lacking hands or tools, demonstrate advanced social behavior. Orcas coordinate hunting strategies using complex signals. Ants build vast underground colonies. Termites maintain ventilation in their mounds without conscious planning. Intelligence isn't required for all of these behaviors, but the underlying systems show how life experiments with organization, cooperation, and problem solving. If intelligence can arise from these foundations, then the idea that Earth might have hosted more than one intelligent lineage becomes more plausible, not as a statement of fact, but as a possibility. Each time life faced a new challenge, a shift in climate, or a dramatic environmental change, new opportunities emerged for different forms of awareness to develop. Some species might have reached a stage where they shaped their surroundings in subtle ways. Others might have developed cultures that existed with little physical impact. Their stories could have been rich and full of meaning for them, even if they left nothing behind for us to find. When you think of intelligence rising more than once, it's not about imagining a world filled with advanced technology. It's about recognizing the evolutionary potential within life itself. Intelligence is a strategy. It helps with survival, communication, navigation, and problem solving. Given enough time, enough environmental variation, and enough opportunity, it's reasonable to think the planet could host multiple waves of cognitive development. We see hints of this in the repeated emergence of traits across species. Eyes have evolved independently many times. Flight appeared in insects, birds, pterosaurs, and bats. Aquatic animals moved onto land, and land animals returned to water. Structures that look similar can arise from completely different origins. Nature solves problems using whatever materials it has, and it often reaches similar solutions through different paths. Intelligence could follow a similar pattern. The first spark that leads to awareness might have appeared long ago in species we've never discovered. Some could have been small, social creatures that communicated in ways we would not recognize. Others might have lived in the oceans where evidence rarely survives. Some might have formed communities that lasted for millennia before being disrupted by natural events. Their entire existence might occupy only a small corner of Earth's history, yet that small span could have held generations of memory, knowledge, and experience. One important point is that intelligence doesn't need to move toward technology. Humans developed tools shaped from stone, but other species might not need external objects. They might rely on memory, vocalizations, or social systems instead. They might adapt physically in ways that reduce the need for tools. They might develop forms of cooperation that don't leave artifacts. A species that became highly intelligent without ever shifting toward material culture would leave almost no trace. Another idea worth considering is the scale at which intelligence operates. We often think of consciousness at the level of an individual, but in nature, many species behave in ways that resemble collective intelligence. Ant colonies function like a coordinated system. Flocks of birds and schools of fish move with patterns that emerge from simple rules. These groups respond to their environments effectively without requiring each individual to understand the whole system. An earlier species could have developed a form of collective decision-making sophisticated enough to solve complex problems, even if no single member possessed what we would call advanced intelligence. Their impact might have been real, even if the geological record holds nothing to show for it. All of this brings us back to the central idea that intelligence rising more than once is not only plausible, but consistent with what we know about evolution. The Earth is old enough, varied enough, and full of enough environmental pressures to allow multiple attempts at building awareness. Some may have succeeded briefly. Some may have developed in ways we wouldn't immediately recognize. Some may have been erased entirely by the shifting of continents or the grinding movement of glaciers. Thinking about these possibilities doesn't change what we know for certain, but it widens the frame through which we see ourselves. Humans are part of a long, continuous stream of life that has been adapting for billions of years. Our intelligence is one expression of that stream, not the only one that could have emerged. Considering other sparks of awareness in Earth's past encourages us to appreciate how rare and fragile intelligence can be. It helps us understand that our own rise is not guaranteed to be permanent. When you picture a civilization, the mind usually jumps to something familiar. Streets, structures, gatherings of individuals working together, tools used for shaping the environment, patterns of behavior that pass from one generation to the next. These are the things we associate with our own society, and it's natural to use them as the basis for imagining anything else that might have existed. But thinking about civilizations that could have risen long before humans means putting aside the versions we know and considering something that might look very different. The deeper the timeline stretches, the more the idea of a civilization becomes broader, less tied to specific images, and more about the underlying behavior that makes any society function. When we talk about civilizations before memory, we're talking about possibilities so far removed from our timeline that even the most basic evidence may be gone. Human memory covers only a small portion of Earth's history. Written records are recent. Oral traditions reach back farther, but even the longest cultural stories represent only a thin slice of time. Everything beyond that relies on the geological record, which is incomplete, uneven, and shaped by forces that care nothing for what lived or built or thought. So the question becomes, if there were civilizations long before humans, what would they have looked like, and why would we expect their remains to be preserved? The honest answer is that we can't expect it. The odds are stacked against preservation. Most materials used by living organisms break down rapidly, especially in warm or wet environments. Even stone structures erode. Metals corrode. Complex materials degrade. On the scale of millions of years, an entire culture could vanish without leaving anything recognizable behind. But that doesn't mean the story would be empty. Civilizations don't require stone or metal to exist. They require shared behavior, communication, coordinated action, and the passing of knowledge across generations. Those things can take many forms. A species could develop complex society without ever producing lasting artifacts. Their technology, if they had such a thing, might not resemble ours. Their structures might have been built from organic materials that decayed quickly. They might have lived in environments where nothing fossilizes. They might have shaped their world subtly, in ways that disappear over time. One possibility is that earlier civilizations could have formed in regions where geological processes are especially active. Coastlines shift constantly. Forests come and go. Wetlands expand and contract. Volcanoes bury entire landscapes. Rivers carve through layers, moving sediment from one place to another. If a society thrived in any of these areas, its traces might be buried, eroded, or recycled into new landforms. The chances of later species discovering clear evidence would be very low. Another possibility is that a civilization could arise in places where preservation is unlikely. Tropical regions are among the worst for preserving remains because heat, humidity, and constant biological activity break down almost everything. The earliest humans lived in such environments, and much of our own early history has been lost because of that. So if an earlier intelligent species lived in similar conditions, much of what they created would vanish. It's also worth thinking about how long a civilization might last. Humans have existed for hundreds of thousands of years, but our most complex societies are far younger. If another intelligent species had a similarly short period of development, their impact might be brief. Even a civilization that endured for tens of thousands of years could have disappeared without leaving anything beyond faint traces that blend into natural patterns. A civilization's lifespan doesn't need to be long to be meaningful. It only needs to be long enough for its members to pass on knowledge, build communities, and create their version of culture. Something else to consider is how different their priorities might have been. Our own society values written language, architecture, agriculture, and technology. These leave marks on the planet, but other species might prioritize different things. A civilization could focus on social bonds, communication, or mobile, flexible structures that move with the environment. They might not build permanent settlements. Their culture might be encoded in behavior rather than objects. They might create music, rituals, or oral histories instead of physical artifacts. Such things would not survive deep time. Some modern animals have complex social structures that function like early forms of civilization. They cooperate, share tasks, and teach skills. Bees create networks of communication that guide their entire hive. Termites build structures with climate control. Dolphins use coordinated strategies in large groups. Elephants pass down knowledge across generations. None of these activities leave behind records we could identify in the distant future, except in rare cases. Yet they represent forms of collective behaviour that could grow more complex under the right circumstances. If an ancient species developed a level of intelligence similar to dolphins or elephants, but went a few steps further, they might have created a society without ever producing durable objects. Their progress might not be visible to modern eyes. It might exist only in the relationships they formed, the decisions they made, and the knowledge they shared. And all of that could disappear without leaving a trace. Another idea worth exploring is that advanced civilizations could rise without ever developing technologies we would recognize. Humans developed tools early in our history because our bodies are suited to manipulating objects. But an aquatic species with no hands might develop intelligence in a completely different direction. They might excel at communication, memory, and coordination instead of physical construction. An underground species might focus on navigation, spatial awareness, and community resilience rather than building complex structures on the surface. Their achievements might be impressive within their environment, yet remain invisible millions of years later. Some species might even develop forms of culture that are largely behavioral. They might create traditions, rituals, patterns of movement, or systems of teaching that pass knowledge across generations. These forms of civilization would be rich and meaningful to them, but would leave nothing detectable in rock or soil. It's also possible that earlier civilizations faced limitations that prevented them from expanding or leaving widespread impact. They might have lived in isolated regions far from areas that later became centers of preservation. They might have been affected by environmental changes that forced them to remain small in number. Or they might have evolved in ways that made them cautious or adaptive rather than expansionist. Not every intelligent species seeks to reshape its world dramatically. No matter how advanced a civilization becomes, it has to contend with nature. Earth's climate has shifted dramatically over millions of years. Ice ages have covered continents, oceans have risen and fallen, asteroid impacts have altered ecosystems, massive volcanic eruptions have changed atmospheric composition. These events can erase entire cultures. Even a highly advanced species might be vulnerable to sudden environmental change. Their cities or structures could be buried, flooded, burned, or crushed. Over geological timescales, even the deepest ruins eventually break down. The oldest structures humans have built are tiny compared to the age of the Earth. They survive only because they exist in the right environments. If earlier civilizations survived their own eras, their remains might still vanish simply because enough time has passed. Earth's surface is constantly being renewed. If their artifacts were buried in sediment, they might now lie far beneath accessible layers. If their structures were on ocean floors, they might have been subducted into the mantle. When you think of civilizations before memory this way, the absence of evidence becomes less surprising. It doesn't confirm that such civilizations existed, but it doesn't rule them out either. The planet is vast. The past is long. The surface older civilizations might have occupied may not even exist anymore. All the continents we see today were once arranged differently. Large portions of the planet's surface have been recycled multiple times. Anything built on those surfaces would be long gone. It's also interesting to think about what a civilization might consider important. Humans leave evidence partly because we build durable structures. But a species that values mobility might never settle in one place long enough to create lasting remains. A species that adapts quickly might not use tools at all. A species that lives primarily in water might not leave archaeological traces we would recognize. A species that uses communication instead of construction might leave nothing behind except disturbances in the environment that vanish quickly. None of this means earlier civilizations likely existed. It simply shows that if they did, they could have lived full, complex lives without leaving anything for us to find. Evolution doesn't guarantee permanence. It produces a wide range of outcomes, many of which leave little trace. Intelligence could follow that pattern. It could bloom briefly in one lineage, vanish, then emerge again in another. Considering forgotten civilizations also encourages us to rethink what it means to be the first. Humans tend to see themselves as the culmination of life's story, the final step in a long process. But life doesn't progress in straight lines. It branches, explores, and experiments. Intelligence, too, might be one of nature's experiments. It might arise, disappear, and arise again. If earlier intelligent species lived and vanished, their disappearance could be part of the natural ebb and flow of Earth's long history. What we know for certain is that the fossil and archaeological records are incomplete. They show glimpses of the past, not the entirety. Every layer of rock represents a moment that survived by chance. Every fossil is one of countless organisms that lived and died without recognition. Every artifact is a rare exception to the rule that almost everything breaks down. When you acknowledge how much is missing, the idea of forgotten civilizations becomes less about mystery and more about perspective. It reminds you that human history is small compared to the vastness of Earth's past. Thinking about civilizations before memory prompts questions rather than conclusions. What forms of intelligence might have existed? How might they have lived? What environments might they have occupied? What pressures shaped their evolution? How long might their societies have lasted? How did they respond to changes around them? These questions don't require answers to be meaningful. They help you see Earth as a place shaped by forces larger than our own presence. They slow your thoughts and widen the frame through which you see the world. As you follow these ideas, your mind may settle into the rhythm of exploring possibilities without rushing towards certainty. It becomes easier to imagine that Earth, with its long and complex history, could have hosted more than one wave of intelligence. Maybe none reached the point of building cities. Maybe some did, but left nothing behind. Maybe some developed forms of culture that would be unrecognizable to us today. When you start thinking about evidence from the distant past, you begin to notice how silent the rocks really are. They sit beneath us with a kind of calm presence, giving the impression that they hold the full memory of Earth. It feels natural to imagine them as permanent records, storing everything that ever happened. But the more closely you look, the more you realize that this impression is misleading. Rocks preserve only narrow glimpses of time, and even those pieces are fragile. The Earth is constantly reshaping itself, and most of what once existed has already been erased without ceremony. This is why the question of earlier intelligent life is difficult to answer with confidence. The evidence we would need might never have survived long enough for anyone to find. The first thing to understand is that the surface of the planet is not stable. It looks solid, but over geological timescales, it moves like something alive. The continents drift, mountains rise and then shrink, oceans form, expand, and disappear. River valleys deepen, widen, or fill in. Wind and water carve the land into new shapes. Volcanic eruptions cover entire regions with new rock. Earthquakes crack and shift the crust. What seems unchanging in a lifetime is constantly shifting when viewed across millions of years. With that in mind, imagine trying to preserve a memory on a surface that refuses to stay still. Even large structures, if left alone long enough, will stop being structures and start becoming part of the landscape. A city left unused eventually collapses. Vegetation takes over. Soil forms on top of the ruins. The stone cracks. Rain breaks it down. Within a few thousand years, the city becomes a faint outline. Within a few million years, even that outline is likely gone. The rock beneath might transform. Pressure might fold the layers. Heat might melt them. The surface could end up several kilometers below what is now ground level. When geologists search for traces of early life, they're often looking at layers that survived by accident. One of the reasons evidence doesn't survive is erosion. Water, wind, temperature changes, and biological activity work constantly to wear away anything exposed at the surface. Rock breaks apart. Soil shifts. Organic materials decay quickly. Even metals corrode. Over long periods, erosion removes entire layers of sediment. It doesn't just damage evidence, it eliminates it entirely. Archaeological sites from just a few thousand years ago can be lost when rivers shift or coastlines erode. Over millions of years, erosion becomes one of the strongest forces on the planet. It consumes everything that isn't protected deep below ground or buried quickly under stable conditions. Another reason is subduction. Much of the Earth's crust is recycled through plate tectonics. Oceanic crust in particular is pulled downward into the mantle and melted. This process erases entire landscapes. Anything that existed on the ocean floor more than 200 million years ago has been destroyed. That includes minerals, sediments, fossils, artifacts, and any hypothetical structures or traces of civilization. Even continents can lose portions of their crust through subduction. If earlier intelligent life had lived near coastlines, on islands, or in regions later absorbed into subduction zones, the evidence would now be gone. Heat plays a significant role too. Many rocks have experienced temperatures high enough to destroy any biological or structural traces. Metamorphic rock forms under intense heat and pressure, conditions that can break apart complex molecules, crush fossils, and erase layered information. Rocks that pass through these conditions lose their history. What once might have contained records of past environments becomes something new, with no sign of what it used to be. This means that large portions of Earth's crust are essentially blank pages that were once full of information. Then there is the matter of preservation environments. Fossils require very specific conditions to form. Most organisms never fossilize. They decay, are eaten, or fall apart long before burial. Even when fossilization does happen, only parts of the organism might be preserved. A shell or bone might survive, but soft tissues rarely do. Entire species have lived and disappeared without leaving a single fossil. Entire ecosystems might never be recorded. If a civilization existed in a place without good preservation conditions, such as a tropical forest or an arid region with little sediment, the odds of finding evidence are extremely low. Many people assume that if an ancient intelligent species built cities, we would find the remains. But the materials most likely to survive, stone and metal, can still disappear across vast timescales. Stone structures crumble, metal objects corrode, ceramics break and disperse. Even large monuments become part of the soil. The more complex the object, the more vulnerable it tends to be. If you take a modern city and imagine it abandoned, the first signs of decay appear quickly. A century after abandonment, buildings collapse. 10,000 years later, almost nothing recognizable remains. A million years later, the surface has changed so much that entire landscapes look new, and any trace of the city is either deeply buried or completely gone. It's also important to consider that the oldest rock layers accessible to us are not as ancient as Earth itself. Much of the early crust has been recycled. The oldest rocks we have found are about 4 billion years old, and these are rare. Most accessible rocks are much younger. This means that the geological record is heavily biased toward recent periods. If a civilization had existed hundreds of millions of years ago, we might access only fragmentary evidence. If one had existed billions of years ago, it would almost certainly be gone. Even looking at more recent times, the record is incomplete. Dinosaurs lived for over 150 million years, yet we have only small portions of their full history. Most species that ever lived are known only through a few fossils. Large creatures might be missing entirely from some regions. Smaller species rarely appear at all. Human ancestors lived in Africa for millions of years, but we have only scattered remains from that time. Fossilization is rare. Survival of those fossils is even rarer. Discovery is rarest of all. So when people ask where the evidence is for earlier civilizations, they often underestimate how fragile evidence truly is. They assume that if something existed, it would leave clear signs. But that assumption relies on the idea that the Earth is a stable archive. It's not. The planet is dynamic and unforgiving to the materials that civilizations produce. Time is a powerful eraser, and the longer the interval, the more thorough the erasure. Another important factor is that even if evidence survives, we might not recognize it. Some traces might appear natural. Artifacts could be mistaken for odd mineral formations. Structures might look like geological patterns. Chemical fingerprints might blend into natural processes. A civilization with technology very different from ours might leave signals we don't know how to interpret. Archaeology relies on context, and context rarely survives deep time. A manufactured object found alone might look like an unusual stone. A pattern carved into rock might be dismissed as a natural fracture. Without consistent signs across multiple locations, identifying something as artificial is difficult. Consider how much debate surrounds certain unusual geological formations today, even those only a few thousand years old. Some natural structures resemble walls or roads, others look like carvings. Without clear context, distinguishing between natural and artificial features becomes almost impossible. Multiply that challenge across millions of years, and the problem becomes enormous. Another thing to keep in mind is the scale at which earlier civilizations might have operated. Humans dominate the planet because our population is enormous, and our impact covers large areas. But an earlier intelligent species might have been limited in number. They might have occupied small regions. Their impact might have been concentrated in one environment. They might not have altered the planet in ways visible from a geological perspective. If their population was small and their distribution narrow, the chances of finding evidence become extremely low. There's also the matter of how much material they would have used. Humans produce a staggering amount of waste and durable materials. We generate plastics, metals, concrete, and chemical byproducts that may persist for a long time, but earlier species might not have produced anything similar. Their tools might have been made from organic materials. Their shelters might have been temporary. Their technology might have been based on materials that degrade quickly. A civilization that relied on wood, fibre, resin, or other biodegradable substances would leave almost nothing behind. Another consideration is that the Earth itself sometimes hides evidence beneath newer materials. Volcanic eruptions cover surfaces. Floods deposit thick layers of sediment. Landslides bury valleys. Desert sands shift and cover landscapes. Each new layer becomes part of the geological record, while the previous one becomes harder to access. Excavating deep layers is difficult and requires fortunate conditions. much of what lies below remains out of reach. An ancient site buried under kilometres of rock would be inaccessible without extraordinary effort. And if the rock has transformed, even extraordinary effort might not help. The more you consider these processes, the more you understand why the geological record is quiet when it comes to the question of earlier civilizations. It's not a matter of hiding. It's a matter of constant renewal. The Earth is always rebuilding itself, and the old layers become part of the interior, part of the mantle, or part of the deep crust. The story written on the surface fades. The deeper you go, the more the pages have been rewritten. This is why the rocks seem silent. They aren't silent because nothing happened. They are silent because they cannot hold everything. Even the traces that do survive often require careful interpretation. A single anomaly in a rock layer might mean many things. A spike in a chemical might come from natural processes. A disturbance in sediments might result from unusual weather. Patterns that look artificial might be natural formations shaped by erosion or mineral growth. Geologists work carefully to distinguish natural variations from the extraordinary, but the deeper the time period, the more difficult the task becomes. Understanding why evidence may not survive helps you see why certainty is elusive when discussing Earth's past. Humans arrived recently. Our history fits into a small part of the geological record. Anything that might have happened before us lies in a vast expanse where preservation is rare, destruction is common, and discovery is improbable. But this doesn't make the question less interesting. It makes it more compelling. It reminds us that Earth is a place with a long story, and most of that story exists beyond our reach. It encourages us to appreciate the fragments we do have without assuming they represent the full picture. As you continue thinking about this, you may notice a shift in the way you view time. Human timescales are short. Geological timescales stretch so far that events separated by millions of years seem almost close to each other. In that vastness, civilizations could arise and vanish without leaving enough behind for us to see. They could live meaningful, complex lives, then fade as the planet changed around them. The quiet we see in the rocks is not a sign that nothing happened. It's a reminder that the Earth forgets most of what it experiences. When you start looking closely at the fossil record, you notice something surprising. Most of what appears in stone is both familiar and unfamiliar at the same time. You see patterns that resemble things you know, but shaped in ways that feel slightly off, or arranged in ways that don't match your expectations. Fossils often show that evolution does not move in a straight line. It doesn't build only toward the forms we recognize. It explores possibilities that sometimes resemble the present, and sometimes diverge so far that the creatures appear alien, even though they lived on the same planet we walk today. Thinking about earlier intelligent species requires a willingness to accept how unpredictable evolution can be, and how many paths it might have taken that left behind traces too strange for us to immediately interpret. When people picture fossils, they usually think of skeletons neatly preserved in stone. But fossils, when taken as a whole, show that Earth's past was full of forms we would struggle to describe without comparison to existing life. Some fossils look like spirals, others like plates or discs. Some resemble ropes. Some have no clear symmetry. Some look like sacs, ridges, or fronds. Many of them appear more like shapes than animals. These unfamiliar forms remind us that life has passed through many phases, some of which have no obvious connection to what came later. The oldest fossils we recognize are simple impressions of microbial mats, faint patterns left behind by organisms that barely interacted with their environment in ways we can see today. Later, fossils reveal creatures that moved, fed, and sensed the world at a very basic level. The deeper you look, the less familiar things become. There are fossils from the Ediacaran period that show organisms shaped like discs, sheet-like bodies that lay flat on the seafloor. Some had galleries of ridges. Some appear to have grown in branching patterns. Others look like inflated segments or quilted structures. It's unclear how many of these organisms relate to modern life. Some might be evolutionary dead ends. Others might be early relatives of later species, but their presence shows that evolution is capable of producing shapes and systems so different from ours that recognizing intelligence within them would be almost impossible. As you move forward in time, the Cambrian period introduces creatures with claws, armour, stalked eyes, segmented bodies, and limbs that fold in unfamiliar ways. Some had mouths lined with sharp structures arranged in circles. Others had flaps that may have been used for movement. Some had spines extending from their bodies in patterns we can't easily compare to existing animals. These fossils remind us that evolution experiments constantly. It doesn't follow a single design. It produces wildly different forms depending on the environment and selective pressures. When you look at these creatures, you realize that if intelligence had arisen in one of these lineages, or something like them, its traces might be difficult to identify. Intelligence would not necessarily come with a recognizable skull shape, or tool-using appendages. It might manifest in bodies we would not immediately associate with complex behavior. As you continue through the fossil record, you encounter periods where life took unexpected turns. The Devonian seas were filled with fish that had bony plates on their heads. Some had jaws that hinged in unusual ways. Others had fins positioned in ways that gave them a functional advantage in specific environments. On land, early plants were nothing like the ones we see today. There were towering structures that were not true trees but something in between. Some grew in patterns that seem almost modular. Others produce spores in structures that have no direct modern equivalent. The earliest land animals had bodies that look almost mechanical in their segmentation. In each of these moments, life was exploring new territory. Evolution was not aiming toward humans. It was responding to challenges, resources, predators, prey, climate shifts, and random variations. In some lineages, complexity grew gradually. In others, it appeared quickly. Some branches thrived for millions of years and then vanished completely. Some left descendants, others left only questions. If you imagine intelligence emerging in these ancient ecosystems, it becomes clear that its physical form could have been very different from ours. It might have developed in creatures with flexible bodies, or rigid exoskeletons, or soft tissues that left no fossils. It might have arisen in species that had no need for bones. It might have appeared in organisms that lived in environments where fossilization almost never occurs. Intelligence does not require a vertebrate skeleton. It does not require hands. It does not require binocular vision or a large brain case. These features belong to humans, not to intelligence in general. The fossil record itself demonstrates that evolution takes unfamiliar paths often. Fossils from different eras show traits that appear once, flourish for a time, and then disappear. Some early fish developed jaws independently. Some arthropods evolved complex eyes long before vertebrates did. Feather-like structures appear in animals that were not birds. Gliding mechanisms developed multiple times in different species. These repeated innovations show that evolution is capable of producing advanced traits through separate lineages. If intelligence is a useful trait, at least in some circumstances, it could also evolve more than once in forms we have yet to interpret. There are also fossils that show social behaviour in early species. Trackways reveal coordinated movement patterns. Certain nests show signs of parental care. Some fossils preserve multiple individuals together, suggesting group activity. These behaviours indicate the early presence of cooperation and communication, two of the key ingredients for civilization. But because the creatures involved were so different from anything living today, their potential intelligence might not be obvious. A social insect from millions of years ago might not leave behind evidence of learning, memory, or problem-solving. A creature that lived in dense forests might have used sound or scent communication that left no physical record. Another important point is that fossils show only body structure, not behaviour. Many intelligent animals today leave almost no physical signs of their intelligence. Dolphins don't leave behind structures. Elephants don't leave detailed artifacts. Crows leave nothing that would survive deep time. Even humans, if you looked only at our bones, might not appear obviously intelligent without the context of our tools and structures. A creature with a unique evolutionary path might have had intelligence that does not show up in its fossils at all. Brain size can be suggested by skull shape, but intelligence is not only about brain size, it's about complexity, connectivity, and behaviour. Fossils cannot capture those features. Many fossils also lack detail. They're often incomplete, fragmented, or distorted by pressure. Soft tissues rarely survive. Any sign of advanced sensory structures might be lost. Subtle features in limbs or joints might not be preserved. Without these details, determining capabilities becomes guesswork. A species could have had advanced manipulation abilities or complex communication mechanisms that left no trace on its skeleton. We cannot assume that unfamiliar fossils represent simple creatures. Complexity can hide in the soft tissues that erosion and geological processes erase. Some fossils look so strange that scientists still debate their classification. There are organisms like hallucigenia with spines arranged in ways that confused researchers for decades. There are ribbon-like creatures that don't fit into known categories. There are fossils that appear as if evolution tried several different approaches to limbs, body plans, and sensory organs. These oddities show that life has gone through phases where experimentation was the rule rather than the exception. If intelligence developed during one of these phases, we might struggle to recognize the physical form connected to it. The fossil record also contains long periods where species appear suddenly and disappear just as quickly. Some animals seem to burst onto the scene with little warning and then vanish without clear descendants. These rapid appearances and disappearances could represent evolutionary innovations that either succeeded briefly or failed due to shifting environmental pressures. If a species with potential intelligence arose during one of these bursts, its impact might have been brief. It might have had a window of opportunity to develop complex behaviours before being pushed aside by competition or environmental change. Its fossils might be rare, scattered, or misinterpreted. Something else to consider is that fossils represent only organisms with hard parts. Soft-bodied animals are vastly underrepresented. Most soft-bodied creatures leave no trace unless buried under exceptional conditions. This means that entire groups of ancient animals might have had complex behaviours that we'll never know about. If a soft-bodied species developed intelligence, it might have left almost nothing behind. Its presence might have been significant in its environment, but invisible in the fossil record. Some fossils also show signs of tool-like structures, though these might be adaptations rather than manufactured items. Certain ancient species had specialised appendages that acted like pincers or digging tools. Others had limbs that could grasp or manipulate. These evolutionary experiments suggest potential for behaviours beyond basic survival. It doesn't prove intelligence, but it creates a backdrop where intelligence is one possible outcome among many. The more you look at fossils from different eras, the clearer it becomes that evolution does not have a preferred direction. It produces diversity that spans far beyond what we see today. Some ancient creatures might appear strange to us not because they were primitive, but because their evolutionary paths were unlike ours. If intelligence rose in one of those paths, its physical form and behavioural expressions might not resemble anything familiar. It might have used senses we don't possess. It might have communicated through methods we don't understand. It might have organised its society in ways that would seem unusual to us, but perfectly natural to them. This leads to another question. What would a fossil of an intelligent species even look like? Humans have large skulls relative to our body size, but that is one solution among many. Birds have high intelligence relative to their brain size. Cephalopods use distributed neural systems. Some mammals rely heavily on social learning rather than physical manipulation. Intelligence doesn't require a specific shape. If you found only the bones of a dolphin or a crow, would you recognise their intelligence without additional context? Probably not. If fossils of earlier intelligent species exist, they might look ordinary without the behaviour that made them exceptional. The more unfamiliar the fossils, the more difficult the interpretation becomes. Evolutionary paths that diverge significantly from our own might produce structures that have no parallel in living organisms. Scientists can only classify fossils based on what they observe in modern species. Anything too unusual becomes a mystery or a category of its own. The fossil record is full of such mysteries. Some have been resolved, others remain open questions. The presence of strange fossils doesn't indicate intelligence, but it does highlight gaps in our understanding. These gaps are where the possibility of earlier intelligent species could fit, not as proof, but as a reminder of how much we don't know. When you consider all of this together, the fossil record becomes something other than a clear map of evolution. It becomes a collection of snapshots taken at irregular intervals, shaped by specific conditions, missing most of the story. The creatures we see in fossils represent only a fraction of the life that existed. The rest is gone. Not because it was unimportant, but because preservation requires luck. If intelligence arose in one of those missing branches, the silence of the fossils would not contradict its existence. It would simply reflect the fact that fossils rarely capture behaviour, and even more rarely capture the most complex aspects of life. This perspective helps you see why the question of ancient intelligent species remains open. The strangeness of many fossils shows that evolution has taken paths we still struggle to interpret. It suggests that intelligence could have appeared in forms we are not equipped to recognise. It encourages a patient approach to understanding ancient life, one that accepts that much of what lived on this planet left no trace for us to study. When you think about where intelligence might have emerged on Earth, it's natural to picture land. We live on land. Our history takes place on land. Most of our discoveries come from land. But the oceans hold far more of Earth's surface, and they have existed for much longer than any modern landscape. For most of the planet's history, land was barren. The oceans, meanwhile, were full of life. If you look at the timeline of evolution, the idea that intelligence could have arisen in the water makes more sense than it might seem at first. The oceans have been home to complex creatures for hundreds of millions of years. They have stability in some places and constant change in others. They offer ecosystems rich enough to support many forms of learning and problem solving. And importantly, they break down evidence quickly, leaving very little behind for future generations to find. This combination of long history, environmental diversity and poor preservation makes the oceans a prime place to consider when imagining earlier intelligent species. Not because we assume any existed, but because the conditions there could have supported them. And if such species ever rose to intelligence, the chances of finding their traces would be extremely low. One of the key differences between ocean life and land life is the role of fire. Humans depend heavily on fire for technology, cooking, metallurgy, and construction. Fire shapes our progress. But in the oceans, fire is impossible. Any intelligent species living underwater would have to develop without it. This requirement changes what technology could look like. It changes how tools might be made. It changes how structures might form. And it changes what traces such a species might leave behind. When you picture an intelligent aquatic species, it helps to set aside human-like assumptions. They would not need fire to cook. They would not need warmth from flames. They would not use fire to harden materials or shape metals. Anything they created would have to rely on materials available underwater. Many of those materials are soft, biodegradable, or easily eroded. This makes the ocean one of the most challenging environments in which to preserve evidence of ancient life, let alone evidence of intelligence. But the absence of fire does not prevent intelligence from developing. Many modern animals show advanced problem-solving skills in the ocean. Dolphins coordinate hunts using complex communication. Octopuses solve puzzles, open containers, and learn from observation. Certain fish demonstrate strategic behaviour. Some species form social groups with long-term dynamics. These examples show that intelligence can thrive underwater, shaped by the surrounding conditions. If you imagine a species that continued evolving beyond what we see today, It could have developed memory, communication, cultural transmission, and cooperation at levels far beyond anything we observe. Such a species might have lived in large social groups. It might have passed knowledge across generations. It might have used natural structures like coral reefs or rock formations as shelters or meeting places. It might have crafted objects from shells, stones, or biological materials. But these objects would not necessarily survive long enough for future species to discover. The ocean environment is constantly moving. Currents transport sand, silt, and organic matter. Waves break down structures. Scavengers clean up anything that dies or decays. Bacteria decompose materials quickly. Pressure increases dramatically with depth, altering how bodies and materials break down. Salinity affects how objects corrode. All of these processes make long-term preservation rare. Even bones can dissolve or fragment under certain conditions. This means the chances of finding evidence of ancient intelligent species in the ocean are far lower than on land. Another factor is the way ocean floors are formed and destroyed. The seabed is constantly renewed. New crust emerges at mid-ocean ridges, spreads outward, and eventually sinks into the mantle at subduction zones. This cycle takes around 200 million years, which might sound long, but it is short compared to the age of Earth. Any evidence left on the ocean floor older than that has almost certainly been destroyed. Even evidence younger than that could be buried beneath layers of sediment or engulfed in volcanic activity. The deeper the evidence lies, the less likely it is ever to be discovered. Considering these geological processes, the idea of ancient intelligent species living in the ocean becomes difficult to rule out entirely, not because there is any proof, but because the environment is so effective at erasing its own past. If intelligence arose underwater millions of years ago, its traces could be gone beyond recovery. Another point worth exploring is the nature of communication underwater. Sound travels farther in the ocean than in air. Marine animals often use sound as their primary method of communication. Whales produce complex songs. Dolphins whistle and click. Fish use low-frequency vibrations. An intelligent species could develop sophisticated communication systems based on sound, pattern, or rhythm. They might use frequencies we cannot detect or interpret. They might use chemical signals. They might rely on subtle movements or colour changes similar to octopuses. These forms of communication could support rich cultural exchange, teaching, cooperation, and planning. However, such communication leaves no trace in the fossil record. It leaves no structures, no markings, no artifacts. If a species developed a complex culture based on sound or movement, all evidence of it could vanish the moment they disappeared. Another possibility is that earlier intelligent species may have lived in deep-sea environments. The deep sea is vast, largely unexplored, and difficult to study. It contains some of the oldest ecosystems on Earth. Hydrothermal vents support life forms that rely on chemical energy rather than sunlight. These ecosystems existed long before land animals evolved. If intelligence arose in these depths, its appearance might have been unlike anything we expect. A species adapted to darkness and high pressure might have developed senses we do not possess. They might have used bioluminescence, electromagnetic fields, or chemical gradients for navigation and communication. If such a species created structures, they might have been built around vents, rock pillars, or the remains of biological communities. These structures might have been made of soft materials or mineral deposits that later dissolved or blended into natural formations. Over millions of years, vents shift position, minerals grow and break, seafloor spreading replaces old crust. Evidence could be lost even if it once existed. Another path for ancient aquatic intelligence might involve species that live near shallower waters. Coastal regions host abundant life and offer resources that could support complex behaviour. But coastlines shift dramatically over time. Sea levels rise and fall, continents move. Entire coastal ecosystems from millions of years ago are now either submerged or exposed, depending on the changes since then. Sediment covers old shorelines. Beaches erode. deltas migrate. Even if structures or artifacts had existed along ancient coasts, they might now be lost beneath thick layers of newer sediment. Some researchers have pointed out that if ancient intelligent species used materials like fibres, wood, plant matter, or shell-based composites, those materials would degrade rapidly. If they used lightweight shelters or movable structures, those would not fossilize. If they used scavenged objects or shaped natural materials subtly, the results might be indistinguishable from natural features once enough time had passed. Modern oceans also illustrate how cultural behaviour can exist without physical artefacts. Certain groups of whales have regional dialects. Some dolphin populations teach specific hunting techniques to their young. These behaviours are not encoded in their bodies but in their social interactions. They are cultural, not biological. If a species like this evolved much further, it might have developed traditions, knowledge systems, and problem-solving strategies without ever building anything permanent. The fossil record does show occasional glimpses of sophisticated marine organisms, but it rarely shows behaviour. Fossils of early cephalopods suggest creatures with complex nervous systems. Fossils of marine reptiles show adaptations for hunting and coordination. The remains of ancient fish show signs of group behaviour, but none of these fossils can show intelligence directly. The best they can offer are hints, like large eye sockets suggesting advanced vision or complex jaw structures suggesting intricate feeding strategies. Intelligence might have existed in species whose fossils look ordinary because their intelligence came from behaviour, not structure. Another thing to consider is how long aquatic species have existed compared to terrestrial ones. Complex life evolved in the oceans hundreds of millions of years before land animals became widespread. This gives marine life a much longer window during which intelligence could develop. The early oceans hosted an extraordinary range of forms, many of which have no direct descendants. Some of these lineages lasted long enough to potentially experiment with more complex behaviours, but because they lived in environments that destroy evidence quickly, we have little record of their full capabilities. It's also worth thinking about extinction events. The oceans have experienced major extinctions that wiped out entire families of animals. Each time life recovered, new forms emerged. If intelligence had appeared in any of these branches, it might have been lost during one of these events. The creatures might have had enough time to develop culture or communication, but not enough time to leave persistent traces. Their extinction would then erase any chance of discovering their existence. When you think about earlier intelligent species in the ocean, it helps to imagine how different their understanding of the world would have been. They might not have developed mathematics or writing. They might not have had agriculture. They might not have needed to store food. They might not have needed shelter beyond the natural structures around them. They could have had deep knowledge of currents, seasons, migration patterns, or the behaviour of other species. Their intelligence might have manifested in navigation, memory, social relationships, or problem-solving. All of these forms of intelligence leave almost no mark in the geological record. They exist only in behaviour, not in objects. And this brings you back to the central idea. The oceans hold most of Earth's history, yet reveal very little of it. They are active environments that erase their own past regularly. They are difficult to study, especially at great depths. They support life forms that decay rapidly. They move and change in ways that make preservation rare. It is striking that even modern scientists are constantly finding new species there, many of them unknown until the moment they are observed. If this is true today, it was even more true in the distant past. Thinking about the oceans in this way helps you see why earlier intelligent species could have existed without leaving clear evidence. It doesn't make it likely, it doesn't make it certain, but it shows how wide the range of possibilities is and how little the geological record can tell us about behaviour, communication, or culture. The oceans remind us that life's history is far larger than our current understanding. They invite patience and curiosity, encouraging us to explore not only what we know, but what we cannot yet see. When you think about lost worlds on land, it helps to picture how many landscapes have existed that are no longer here. Continents have shifted, collided, broken apart and reformed. Mountains have grown and worn down. Forests have spread and vanished. Deserts have expanded and then turned into fertile regions before drying out again. Grasslands have emerged where wetlands once stood. Entire landscapes have come and gone without leaving much behind. The modern world holds only a fraction of the environments that existed throughout Earth's history. Most of them disappeared long before humans arrived. If a civilization had existed in any of those older worlds, its footprints could easily have been erased. The land we walk on feels permanent because it changes slowly compared to human lifetimes. But over millions of years, land changes constantly. Volcanoes build new land, rivers carve deep valleys, glaciers scrape entire regions down to bare rock. Wind reshapes dunes, earthquakes create new faults, hills become plains, plains become basins. Every landscape, no matter how stable it appears, is temporary. When you consider the possibility of ancient civilizations on land, this constant change becomes important. It means that even large structures could vanish without leaving recognizably artificial traces. One of the biggest reasons land-based civilizations could disappear is erosion. Erosion isn't just a process that smooths rocks and moves soil. It can remove entire layers of the surface. Structures built from stone, clay, or organic materials eventually break apart. Walls collapse. Roofs fall in. Floors crumble. Vegetation grows through cracks. Roots destabilize foundations. Over time, even large buildings become piles of rubble. After enough time passes, even those piles disappear. Rocks that once formed walls become part of the soil. Soil moves downhill. Streams wash away debris. Rain and wind wear structures down until they become part of the surrounding terrain. After a long enough period, the land no longer reveals what was once there. Another factor is burial. Sediment can accumulate rapidly in some regions. Landslides bury valleys. Floods cover large areas with mud. Volcanic ash blankets entire landscapes. Dust storms deposit thick layers of material. In some places, sediment builds up slowly over millions of years, covering older surfaces with layers that hide everything beneath them. If a civilization existed in an area where sedimentation was common, its remains could be buried deep underground. Excavating such remains would require drilling or digging through rock layers far thicker than what humans typically disturb. Even then, identifying artifacts would be difficult if the materials degraded over time. A more dramatic form of burial comes from volcanic activity. Eruptions can cover vast regions with lava or ash. Lava destroys almost everything it touches. Ash can collapse structures under its weight. Over time, volcanic material can solidify, becoming new rock that seals whatever lies beneath. If a civilization existed near an active volcanic region, its remains might be completely encased in hardened lava. Millions of years later, geological processes could push that rock deep into the crust. At that depth, heat and pressure would transform it, destroying any recognizable features. Another reason earlier civilizations could vanish involves how easily organic materials break down. Many early human societies built with wood, thatch, mud, and plant fibers. These materials degrade quickly unless preserved under unusual conditions. If an earlier intelligent species also relied on organic materials, their structures might have disappeared within decades after abandonment. Even if their population was large, their presence might leave almost no physical evidence after a few thousand years. Over millions of years, the chance of survival becomes even smaller. There is also the issue of forests. Forest environments are rich in life but poor at preserving artifacts. Wood and plant matter decompose quickly. Wet conditions accelerate decay. Fallen trees break apart and return to the soil. If an ancient species lived in a forested world, much like modern rainforests or temperate forests, their structures and tools could vanish rapidly. Even stone tools can be difficult to find in forests because vegetation covers them, soil forms over them, and erosion moves them. If the species use materials that did not endure, their entire culture might disappear without leaving clear traces. Another environment that hides evidence well is wetlands. Swamps, marshes, and river deltas are constantly shifting. Water moves sediment. Organic material breaks down. Layers of mud form, then wash away. Vegetation grows thickly. These regions can support large populations, but their archaeology is challenging even for recent human history. Ancient wetlands that existed millions of years ago now lie deep beneath modern landscapes or under the sea. If an intelligent species lived in a wetland ecosystem, their remains might be unreachable or destroyed. Deserts present another challenge. They seem like stable environments where artifacts might survive, but deserts shift dramatically over time. Sand dunes migrate, dry lakes fill and disappear. Flash floods reshape the land. Wind moves enormous amounts of sand, burying structures or exposing them only to bury them again later. Some deserts also experience extreme heat that accelerates the breakdown of organic materials. If a civilization lived in a desert that existed millions of years ago, it might now lie beneath layers of sediment, or the region might have turned into something completely different. Another problem is the movement of continents. Land that once held forests, lakes, or fertile plains might now form mountain ranges. When continents collide, the crust folds and lifts. Rock layers tilt, twist, and break. Structures that once sat on the surface could end up thousands of meters above sea level or deep inside mountain ranges. The pressure and heat inside mountains can erase any evidence of previous occupation. What remains might look like ordinary rock, indistinguishable from the rest of the geology. It is also important to think about the role of climate. Climate has changed many times throughout Earth's history. Ice ages covered large areas with glaciers. Glaciers grind everything beneath them, removing soil and rock down to bedrock. They crush structures and scatter debris. When glaciers retreat, they leave behind reshaped landscapes with little trace of what existed before. Other times, warm periods cause sea levels to rise, flooding coastal regions. Many ancient landscapes now lie underwater. If a civilization thrived in one of these areas, much of its record could be lost or unreachable. Some lost worlds existed long before modern ecosystems formed. For example, vast coal swamp forests once covered parts of the continents. These forests had enormous plants unlike anything alive today. If a species had evolved intelligence in those forests, the environment would have been ideal for supporting complex life. But the swamps eventually turned into coal deposits through geological processes, compressing and heating plant material over millions of years. Any artifacts or structures left behind would have been crushed, altered, or incorporated into the coal seams. The geological transformation of these environments makes them nearly impossible to examine in detail. Similarly, large inland seas existed at various points in Earth's history. These seas supported abundant life. Their shorelines changed constantly. As they dried up or shifted, sediments covered the old coastlines. If any species lived along those edges, the geological record might hold only faint traces buried deep within rock layers. Accessing these layers requires drilling or quarrying that rarely reaches the right depth or location. Another idea worth considering is the scale of earlier civilizations. Humans create enormous amounts of material waste. We produce metals, plastics, concrete, and synthetic substances that leave clear marks. But earlier species might have lived differently. They might have been more in balance with their environment. They might have created small communities rather than large cities. They might not have used long-lasting materials. They might not have expanded across continents. A civilization with a population far smaller than humanity could leave little trace on the global record. Even within human history, some societies left almost nothing behind. Nomadic cultures travelled with the seasons. Their possessions were few, their structures were temporary. They left behind almost no durable artifacts. If these societies vanished entirely, and if no written records existed, future species might never know they lived. If earlier intelligent life resembled these societies in lifestyle, they might have left even fewer traces. Another point involves the nature of technology. Humans rely on tools and structures partly because of our physical limitations. We need clothing, shelter, controlled temperature, weapons, containers, and transportation. But another species might have different needs. They might have had natural defences against weather. They might have had bodies suited to their environment without requiring artificial protection. They might not have required tools for many tasks. If their technology was minimal or expressed in behaviour rather than objects, the archaeological record would not show evidence of their existence. There's also the possibility that earlier intelligent species might have used natural features rather than building their own. Caves, rock shelters, trees, or natural formations might have served as living spaces. They might have shaped the environment gently rather than dramatically altering it. If they created pathways or cleared areas, those changes might blend into natural patterns. Over millions of years, these subtle modifications would disappear. When you think about how many land environments have come and gone, the sheer number of lost worlds becomes clear. Some existed in climates unlike anything today. Some hosted species we have never seen. Some were flattened, buried, or eroded to nothing. Others became part of mountain ranges or ocean floors. For each of these worlds, the chance of preserving evidence from intelligent species is low, and the chance of discovering that evidence is lower still. Even if evidence survived in rare pockets, the geological record is incomplete. Only a small percentage of Earth's surface has been studied in detail. Many regions remain unexplored or inaccessible. Dense forests, remote deserts, high mountains, and deep canyons hold potential discoveries that have never been examined. Human exploration covers only a thin layer of the planet, both physically and scientifically. All of this creates a picture of land as a place full of hidden histories, not histories that we assume contain civilizations, but histories that demonstrate how easily entire landscapes disappear. The land does not preserve everything that happens on it. It preserves only what survives erosion, burial, heat, pressure, and time. Most of the story is missing. When you step back and think about earlier intelligent species within this context, the absence of evidence becomes less definitive. It doesn't confirm anything. It doesn't deny anything. It simply reflects the fact that the land has changed too dramatically and too often for the full history of life to be preserved. It encourages a patient, open-minded perspective, one that accepts how much time has passed and how little of it we can see. When you begin to think about Earth on its true scale, the numbers become almost impossible to hold in your mind in any comfortable way. 4.5 billion years is so long that even familiar historical periods start to feel like brief moments. Civilizations rise and fall in a blink compared to the age of the planet. Species appear and disappear before anything beyond their bones can be noticed. Entire environments form, thrive, transform and vanish in spans that feel endless to us, yet occupy only thin layers in the geological record. When viewed through this wider lens, the idea that humanity might not be the first intelligent species seems less like an extraordinary suggestion and more like a question shaped by perspective. It's a matter of comparing how little time we've been here with how much time came before. One way to see the scale clearly is to imagine compressing Earth's history into a single calendar year. Humans would appear only in the last few moments of the last day. Recorded history covers only seconds. Everything we know about ourselves occurs in a time frame so small that it nearly disappears on this compressed timeline. But the older parts of the year, the earlier months and the earlier days were filled with life, change, and opportunity. During those long stretches, countless species evolved, thrived, and vanished. There were entire lineages that rose to remarkable complexity before their worlds shifted beyond what they could survive. If intelligence is a trait that can emerge under the right conditions, then these enormous spans of time create many openings for its development. Life has had billions of years to experiment with different forms, structures, behaviors, and strategies. It has faced changing climates, shifting continents, new predators, and new environments. Each challenge created selective pressures that could, under some circumstances, favour more complex thinking, communication, or problem-solving. Intelligence is not guaranteed to appear, but it is also not restricted to a single moment or a single lineage. When you look at the fossil record, you see only scattered evidence of this long experimentation. The fossils that survive represent a tiny fraction of ancient life. They show us creatures that once lived, but not the full range of their behaviours or potential. Many gaps exist, not just in the record, but in our understanding of how life adapts. These gaps become more understandable when you think about the length of Earth's history. Long spans without fossils do not indicate inactivity. They indicate missing pages in a book that has been rewritten many times. Another way to understand the scale is to think about how short human existence has been in comparison. Modern humans have existed for around 300,000 years. For most of that time, our species lived in small groups, hunting, gathering, adapting to the environment, and gradually developing culture. Agriculture began only about 12,000 years ago. Writing began around 5,000 years ago. Cities are even younger. Our technological age, with its machines and devices, covers only the last fraction of a single second on that compressed calendar. If earlier intelligent species lived in similar time frames, their entire existence could be a brief moment in the geological record. A species could evolve intelligence, develop culture, and disappear within 1 million years or even less. On the scale of Earth's timeline, 1 million years is a short interval. It's long enough for a species to develop complexity, but short enough for evidence to vanish afterward. The rocks do not show continuous preservation, and many layers are missing entirely. Even major evolutionary events sometimes leave only faint traces. If intelligence arose briefly in one lineage, the record might not reflect it in any recognizable way. Another aspect of cosmic timescales is the number of extinction events Earth has experienced. At least 5 major extinctions are well known, and several smaller ones shaped the planet significantly. During each extinction, a large percentage of species disappeared. The causes varied: volcanic activity, climate change, asteroid impacts, loss of oxygen in oceans, and shifting sea levels. These events reshaped ecosystems, eliminating lineages that had persisted for millions of years. Some extinctions removed highly successful species that seemed well adapted. Others cleared ecological space that allowed new species to emerge. If intelligence had arisen in a lineage that vanished during one of these events, the evidence of that intelligence could have disappeared with it. The environment might have changed too quickly for survival. The species might have been too specialized to adapt to new conditions. Their cultural or behavioral achievements, however meaningful to them, would not leave durable traces. Over millions of years, their presence would dissolve into the background of the geological record. The pace of change also matters. Evolution can move slowly, but under the right conditions it can accelerate. Warm periods, abundant resources, or isolated environments can create opportunities for rapid diversification. Conversely, stable environments might allow species to maintain complex behaviours for long periods. If a lineage developed intelligence in one of these favourable windows, it might have had enough time to form a civilization according to its own needs, but not enough time to alter the planet in a detectable way. Continental drift adds another layer to this picture. The position of the continents has changed dramatically over geological time. What is now a cold region may have been tropical. What is now dry land may have been ocean. Mountain ranges formed where plains once stretched. Rivers changed course. Lakes formed and drained. Islands appeared and disappeared. The places where ancient species lived might no longer exist as they once were. Their traces could be buried deep underground, submerged or destroyed by tectonic processes. The shifting of continents over billions of years makes the preservation of ancient civilizations unlikely. even if they once existed. It is also helpful to consider the diversity of past life. At several points in Earth's history, life expanded rapidly into new forms. The Cambrian explosion introduced an extraordinary variety of body plans. Later periods saw the rise of large fish, marine reptiles, dinosaurs, early mammals, and many other groups. Each of these periods lasted long enough for complex traits to evolve. Some species developed advanced sensory systems, others formed social groups, others displayed behaviors that suggest learning and cooperation. These traits can be stepping stones toward intelligence, depending on environmental pressures. But not all paths lead in the same direction. Some lineages evolve complexity that serves specific ecological roles without expanding into broader forms of intelligence. Others develop intelligence but remain small in numbers or restricted in habitat. Over long time frames, many possibilities exist. If intelligence is not a rare trait, but one of many evolutionary experiments, then Earth's history could hold several moments where intelligent species appeared briefly and then faded. Another element of cosmic timescales is the impermanence of the surface. The oldest rocks on Earth are rare. Many early surfaces have been recycled. The crust has been reshaped many times. Even rock layers that remain may have been altered by heat and pressure. Anything fragile would be destroyed under such conditions. If earlier intelligent species built structures from materials less durable than stone, those structures might not survive. Even stone structures could disappear if buried deeply enough. Time and pressure turn stone into different forms. Minerals recrystallize, layers fold. What was once a building could become unrecognizable rock. Over 4.5 billion years, the accumulation of small changes creates sweeping transformations. The planet you see today is only the most recent version of Earth. Before this version existed, there were countless others. Each earlier Earth had different continents, climates, oceans, and ecosystems. The species that lived in those worlds adapted to conditions that no longer exist. Their behaviours might be difficult to imagine because the contexts that shaped them are gone. If intelligence is shaped by environment, then earlier intelligent species might have had priorities that differ from ours. Their intelligence might have been directed toward survival strategies suited to ancient worlds. Perhaps they needed to navigate dense forests, coordinate in swamps, or adapt to ecosystems filled with predators unlike anything today. Their intelligence might have been more focused on communication, memory, or sensory interpretation than on tool use. These forms of intelligence could support complex societies without producing long-lasting artifacts. Another important aspect of cosmic timescales is the concept of repeated opportunity. Over billions of years, the planet has gone through cycles that create and destroy possibilities. Warm climates create abundant life. Cold climates isolate or reduce populations. Changing sea levels transform ecosystems. Each cycle creates selection pressures that could encourage intelligence to emerge in different forms. A species might evolve problem-solving abilities during one cycle and lose them in another. Intelligence is not necessarily a permanent feature. It could rise and fall depending on conditions. If intelligence developed more than once, each occurrence might leave different types of traces. Some might be subtle, some might not survive, others might be too scattered to interpret. The geological record rarely shows behaviour, and even less frequently shows complex behaviour. Intelligence could appear in the gaps, living in spaces where preservation was unlikely, disappearing before any recognisable signs could be preserved. Considering the sheer length of Earth's history, it becomes easier to accept how much could have happened without leaving clear evidence. Entire ancient worlds existed before the modern continents formed. Complex ecosystems thrived and vanished. The fossil record captures only fragments. The surface holds only a narrow slice of the past. Most of Earth's history is invisible to us. This invisibility does not imply anything specific. It simply reflects how enormous the planet's timeline is compared to our ability to perceive it. The further back you look, the fewer details survive. By the time you reach hundreds of millions of years, even major events can become difficult to reconstruct. Earlier intelligent species, if they existed, would be part of these lost details. When you consider all of these factors, geological transformations, environmental changes, extinction events, the recycling of crust, the decay of materials, and the brevity of human history, the question of ancient intelligence becomes less about proving or disproving and more about understanding scale. The planet has had more than enough time for many beginnings. Some might have led nowhere. Others might have led to complex societies that rose and fell long before modern species appeared. In this long view, intelligence doesn't have to be unique to humans or restricted to a single emergence. When you think about the idea of intelligent life elsewhere in the universe, it feels natural to imagine a crowded cosmos. With so many stars, so many planets, and so much time, it seems almost obvious that life should appear again and again. The mathematical possibilities alone suggest that Earth cannot be the only place where complex organisms emerged. And yet, despite all of this potential, we have found no confirmed signals, no clear signs, no unambiguous evidence of civilizations beyond our own. This silence is what people often call the Fermi paradox, summarized by a simple question. If the universe is full of worlds, where is everybody? When you consider earlier intelligent species on Earth, this paradox gains another layer. It raises the possibility that the obstacle to finding others might not lie out there at all, but here in how intelligence behaves, how it evolves, and how easily it can rise and fade. The paradox reflects something about time, frequency, survival, and the limitations of any civilization, including our own. Thinking about ourselves as the answer to the paradox means examining what kind of species we are, how fragile intelligence can be, and how the long quiet of the universe might not be surprising if intelligence does not tend to last very long in any particular place. One of the first things to consider is how long civilizations actually endure. Human civilization as we recognize it today is extremely young. Our technological era covers only a tiny fragment of our existence. If you step outside the human perspective and look at the broader pattern, our entire industrial footprint fits into an almost invisible moment on cosmic scales: radio communication, which marks the beginning of our ability to send detectable signals into space, spans just over a century. Compared to the billions of years available for life to develop, that century is a faint flash. If other civilizations had similar timelines, even if they were numerous, their periods of detectability might be short. They might last only a moment in astronomical terms. Their signals might travel beyond their worlds but fade before reaching another civilization. They might have risen and disappeared long before we emerged. The quiet we observe might not reflect the absence of life, but the difficulty of overlapping with it at the right moment. Civilizations could be rare not because intelligence is rare, but because intelligence does not maintain stable, long-lived technological presence. This perspective aligns with what we know about Earth's history. Species rise, adapt, flourish, and vanish. The timeline of dinosaurs, for example, stretches across hundreds of millions of years, yet none of their behavioral patterns left behind anything resembling technology. Their disappearance opened space for mammals to expand. That expansion eventually led to humanity, but the mammals that emerged did not replace dinosaurs immediately. It took millions of years for complexity to build, and when it did, the result was influenced by many unpredictable events, including climate shifts, ecological changes, and geological activity. If intelligence requires a specific set of conditions, and those conditions are fragile, then civilizations might not be durable parts of planetary history. They might appear only briefly. This briefness contributes to the silence. If a civilization lasts for a few thousand years, or even a few 100,000 years, it is still an extremely short period compared to the lifespan of a star. Two civilizations would have to exist at the same time and be capable of detecting each other. If their windows of detectability do not overlap, They may never know about one another. Another factor is energy use. Civilizations that grow technologically tend to consume more energy. That energy must come from somewhere. Depending on how a species accesses energy, it might change its planet's climate, atmosphere, or ecosystems. Humans have reached a point where our activities influence the entire planet. These impacts create challenges that require advanced cooperation and planning to navigate. If a civilization fails to manage its energy use or resource consumption, it might collapse long before becoming visible to others. This idea connects directly to the possibility of earlier intelligent species on Earth. If a species became advanced but failed to manage its environment, its remains might be subtle. Its collapse could erase its own traces. If civilizations elsewhere face similar limitations, the universe might be full of intelligent species that never reach a stable, long-lasting phase of technological growth. They rise, expand briefly, and then disappear before becoming detectable across space. There is also the possibility that civilizations choose not to broadcast their presence. Humans began by sending out unintentional radio noise. Over time, our technology has become more efficient, reducing the amount of energy wasted as radio leakage. As we move toward fiber optics, narrow beams, and encrypted communication, our detectability decreases. Another civilization might have followed a similar path, creating periods of brief detectability followed by quieter phases. If most civilizations become quieter over time, the universe might contain many forms of intelligent life that we cannot detect because they do not announce themselves broadly. Some civilizations might not seek contact at all. They might be cautious, protective of their world, or uninterested in communication beyond their own species. Their motivations could be shaped by evolutionary pressures we cannot guess. Their survival might depend on remaining unnoticed. If civilizations choose silence as a strategy, then the quiet of the universe becomes less mysterious. Another aspect of the Fermi paradox involves the physical limitations of space travel. The distances between stars are vast. Even travelling at a significant fraction of the speed of light would require enormous energy. Civilizations might not find interstellar travel practical. They might explore their own systems but not venture far beyond them. Their technological footprints might remain small, confined to regions impossible for us to observe at our level of detection. This connects to humanity's situation. We have sent probes into our solar system, visited our moon, and studied nearby planets. But the idea of reaching another star is far beyond our current capabilities. If this limitation is common, civilizations might be bound to their home systems. Their impacts remain local. They do not build large structures that alter their galaxies. They do not leave marks visible across light years. Their presence would be almost impossible to detect from afar. Another idea is that civilizations may exist in forms unlike our own. They might be biological, synthetic, hybrid, or based on systems we have not imagined. Their communication methods might be incompatible with our technology. They might use frequencies or patterns that we cannot detect. They might exist in environments that distort or absorb their signals. They might interact through means that leave no trace on the electromagnetic spectrum. In such cases, the silence we perceive might be an illusion created by our limited understanding. When you consider these possibilities, humanity becomes a mirror that reflects the challenges faced by any intelligent species. The obstacles we encounter, environmental stability, resource management, energy use, communication, and technological maturity, are likely faced by others as well. If civilizations appear and disappear quickly, or remain local in their impact, or choose to remain silent, then the absence of evidence elsewhere becomes expected rather than surprising. This perspective also raises another question. If intelligence struggles to last long enough to become detectable, then perhaps the reason we have not found others is that we are early in our journey, and the challenges ahead are substantial. The Fermi paradox might not be about the rarity of life, but about the difficulty of sustaining complexity. The mirror reflects our own vulnerability. It reminds us that survival requires long-term stability, cooperation, and adaptation. Technology creates opportunities but also risks. If civilizations cannot navigate those risks, they might vanish before reaching advanced stages of development. This brings the conversation back to ancient Earth. If earlier intelligent species existed and disappeared, their presence could teach us about the fragility of intelligence. Their absence from the geological record does not deny their possibility. It highlights how easily civilizations can be erased. Their disappearance might mirror the challenges that await any species that reaches a certain level of complexity. Intelligence might be a delicate balance, requiring both environmental stability and wise decision-making. Another aspect to consider is planetary history. Earth itself has gone through long periods where life nearly vanished. The Permian extinction eliminated most species. The late Devonian extinction reshaped marine ecosystems. The Cretaceous extinction ended the age of dinosaurs. These events were not caused by intelligent behavior, but by natural forces. If intelligent species existed during any of these periods, their survival might have been threatened by events far beyond their control. Their disappearance would leave little trace. On a cosmic scale, the universe contains many potential threats to long-term survival. Supernovae, gamma-ray bursts, asteroid impacts, and changes in stellar radiation can all affect life. Civilizations might face these dangers regularly. If extinction is common at planetary or stellar levels, then lasting civilizations might be rare. Intelligence could appear frequently but struggle to endure. This pattern could explain why the universe appears quiet. Civilizations rise, reach a certain level of development, and then fade. Their moment of visibility is brief. The next civilization might arise millions of years later, too distant in time for communication to overlap. If this cycle repeats across the galaxy, the result would be a universe full of life but empty of long-term signals. The silence we observe would reflect timing rather than absence. It is also worth considering how intelligence interacts with its environment. Complex thinking allows species to adapt, innovate, and solve problems. But it can also lead to behaviors that strain ecosystems. Overexploitation of resources, pollution, habitat destruction, and changes to climate can threaten long-term stability. If civilizations struggle with these issues, they might collapse under their own impact. The remains of their society might be minimal, particularly if they use materials that do not endure. If a similar process occurred on other planets, their civilizations might leave no detectable traces. Humanity's situation highlights this issue. Our technology gives us the ability to alter the planet on a global scale. Managing these changes requires cooperation, foresight, and adaptability. If other civilizations face similar challenges, their ability to survive might depend on choices they made during critical periods. Some might have succeeded, others might have failed. The ones that failed may have disappeared without leaving detectable marks in the cosmos. Another possibility is that civilizations reach a point where they no longer prioritize expansion, communication, or visibility. They might turn inward, focusing on their own experiences rather than exploring outward. Their technology might become efficient, reducing emissions or signals that escape their atmosphere. They might achieve stability without altering their surroundings dramatically. From an outside perspective, their planets might appear quiet even though intelligent life exists. This quiet would not reflect a lack of intelligence but a preference for subtlety. This possibility aligns with what we see in nature. Many species achieve stability by living within their means. They adapt to their environment without drastically altering it. A highly intelligent species might find a similar equilibrium. They might see little reason to broadcast their existence. They might prefer peaceful coexistence with their planet rather than large-scale technological expansion. If this pattern were common, the universe would appear quiet even if intelligent life were widespread. All of these ideas contribute to the concept of the Fermi mirror. When we look at the paradox, we're not just asking where other civilizations are. We're also asking who we are, how we behave, and what our limitations are. The silence of the universe reflects the challenges faced by any species that reaches a certain level of complexity. It reflects the smallness of our timeline, the fragility of our existence, and the difficulty of sustaining detectable presence across cosmic distances. This view does not lessen the possibility of life elsewhere. It simply reframes the question. Instead of wondering why no one has contacted us, it encourages us to consider how hard it is for civilizations to align in time and capability. It points to the vast stretches of cosmic history where intelligent species might have appeared on countless worlds, only to vanish long before we existed. It suggests that the search for others might take patience and long-term effort. When you start considering why the idea of being the first intelligent species on Earth feels so strange, the answer usually begins with something quiet and internal rather than scientific. People tend to assume that intelligence is supposed to be shared. They assume that consciousness is something that should appear in more than one place, not only across the universe but across the long stretches of Earth's own history. There is something comforting in imagining predecessors, a sense that other minds might have walked similar paths, faced similar questions, and wondered about their place in the world long before we appeared. When you take that comfort away, the feeling of being first can bring a kind of unease, because it makes intelligence feel more fragile, more accidental, and more isolated than we expect. Part of that unease comes from how humans view themselves. People often build identity around connection. Community, family, shared history, shared culture, and shared experience all shape how we understand who we are. When you apply that instinct at a species level, it makes sense that humans would want company in the past as well as in the present. The thought that no other intelligent beings existed before us can feel like a story missing its earlier chapters. It creates a sense of arriving in the middle of a long journey without anyone to explain what happened beforehand. Another part of the discomfort comes from the way intelligence is framed in modern science. Humans often describe intelligence as if it were inevitable, as if evolution were always moving toward something like us. But the evidence does not support that assumption. Evolution has no direction. It creates traits that help organisms survive in their environment. Intelligence helped humans succeed, but that does not mean it had to happen. When people consider the possibility that we are first, it forces an acknowledgement of how improbable intelligence may actually be. That improbability challenges assumptions about purpose and direction and can make people uneasy. It also feels unsettling because being first places a kind of responsibility on humanity that is difficult to define. If no other intelligent species existed before us, then we are the first minds capable of understanding the planet in a scientific sense. We are the first to study its history, its ecosystems, its geological processes, and its long timeline. That makes the world feel unexpectedly new, even though it is ancient. Being first means there were no earlier civilizations to make mistakes we could learn from. There were no previous examples showing what works or what fails for intelligent species over long stretches of time. Everything humans do becomes a test without precedent. That lack of guidance can create a sense of uncertainty about the future. The concept of being first also interacts with modern curiosity. People naturally want to explore. They want to discover how things came to be and where they fit within those stories. When you tell someone that humanity might be the first intelligent species on Earth, the mind tends to drift toward what might have been. It wonders why intelligence did not arise earlier. It wonders what conditions made it possible now and not before. It wonders whether intelligence is a rare development or a fragile one. These questions do not always feel threatening, but they can create a sense of incompleteness, as if something about the story is missing. Another reason the idea feels unsettling involves comparative perspective. Much of human identity is shaped through comparison. People compare themselves to others, cultures compare themselves to other cultures, and species are often discussed in terms of their similarities to or differences from others. If humans are first, there is no earlier comparison available. That creates a quiet sense of standing alone in a vast timeline. It can make intelligence feel like a single experiment rather than a well-tested pattern. Because humans are used to comparing themselves to something, the absence of that comparison can feel disorienting. There is also an emotional reaction to the thought of being alone in a long history. Loneliness does not require physical isolation. It can come from the sense that no one else has shared the experience you're having. If humanity is the first intelligent species on Earth, then the long past is filled with life that experienced the world very differently. They moved, fed, reproduced, and adapted without consciousness or awareness in the way we understand it. They did not ponder the stars, question their existence, or build cultures that recorded thoughts. The idea that no earlier minds went through these experiences can make human intelligence feel like a sudden break in the chain, something that emerged without precedent. That break can feel strangely quiet, as if something that should have had a long build-up simply appeared without warning. In many ways, humans are not used to being first at anything. Most experiences in life involve following patterns set by others. People follow traditions, study examples, and build on what came before. When someone reaches a new place, they often look for signs of who came before them. That instinct extends to the entire species. When people imagine a long Earth full of evolving life, they expect to find traces of minds that preceded theirs. When those traces are absent, it feels like an empty space where something should be. The absence becomes almost as noticeable as the presence would have been. Another psychological factor is the way humans tell stories. Narratives usually involve sequences. One thing leads to another. Characters grow from earlier experiences. Cultures build on older traditions. Human storytelling is built on continuity. When you remove earlier intelligent species from Earth's past, the story feels like it starts abruptly. It doesn't follow the familiar pattern of one civilization rising after another. It feels more like a beginning placed at the end of a long quiet period, which can create a sense of imbalance in the narrative structure people rely on to make sense of the world. The feeling of unease also ties into survival instincts. Being first can feel like being untested. Without precedent, there is no roadmap for how intelligence unfolds over long timescales. People prefer to understand patterns. They want to know whether intelligent species typically endure, collapse, or transform. They want to know whether civilizations tend to last or fade. If humans are the first, those patterns do not exist. There is nothing to point to and say, this is what usually happens. That uncertainty encourages caution, but also discomfort, because it leaves the future open in ways that feel unpredictable. The idea of being first also interacts with how humans think about significance. People often search for meaning. They want to feel connected to something larger, something ongoing. When you imagine earlier intelligent species, it creates a sense of continuity across time. You become part of a long chain of thinking beings. When that chain begins with humans, it makes our emergence feel both remarkable and precarious. Remarkable because we represent a new kind of awareness. Precarious because there is no evidence that intelligence naturally appears repeatedly or consistently. If we are first, then intelligence might be more fragile than we assume. That fragility can feel unsettling. There is also a deeper emotional layer tied to expectation. Many people grow up with stories about ancient civilizations with hidden knowledge or lost wisdom. These stories shape the imagination. When people think about earlier intelligent life, they sometimes picture advanced societies that left clues or artifacts. When those clues do not exist, it conflicts with the expectations built through mythology, fiction, and cultural tradition. Even though these stories are not evidence, they influence how people expect the past to feel. The absence of earlier intelligence disrupts that imagined pattern. Another psychological factor is trust in natural processes. People often assume that complex traits should appear consistently, because natural laws are consistent. If intelligence appeared once, some expect it should have appeared earlier or more often. When it doesn't, they question whether something unusual or unexpected happened. This expectation creates tension between what people believe should happen and what the evidence shows. That tension can feel uncomfortable, because it challenges intuitive ideas about how evolution works. At the same time, being first can also feel isolating on a cosmic scale. The universe is vast. When people think about intelligent life elsewhere, they hope for connection. They want to believe that other species have existed, struggled, wondered, questioned, and hoped. If humans are first on Earth, the mind extends that idea outward. It begins to wonder whether humans might also be early in the universe. If intelligence arises rarely, then maybe the universe is quieter than expected. That quiet can feel unsettling, because it creates an image of a universe where thinking beings are few and far between. People often prefer the idea of a lively universe filled with minds exploring and learning. A quiet universe feels emptier, colder, and less shared. Another emotional reaction comes from the concept of responsibility. If humans are first, then everything we do becomes part of the earliest chapter of intelligent life on this planet. That thought can carry weight. It suggests that humanity is setting a precedent, whether intentionally or not. Our actions shape the future not only for ourselves but for any species that might evolve intelligence after us. That responsibility can feel overwhelming. It makes each decision feel larger than it would otherwise. People are not always comfortable with responsibility on this scale, especially when they did not choose it consciously. The idea of being first also affects how people view their place in nature. If intelligence emerged naturally and repeatedly, then humans would be part of a long tradition. But if intelligence is rare, then humans might represent something unusual, an anomaly rather than a typical outcome. Being an anomaly feels both special and unsettling. It raises questions about why intelligence happened at all, what combination of events produced it, and whether it can last. People often struggle with the idea that something so central to their identity might be fragile or impermanent. Another psychological element comes from how people react to the unknown. The human mind tends to look for patterns, explanations, and continuities. When evidence is missing, people fill the gaps with imagination. Sometimes they imagine earlier civilizations or older forms of intelligence. Other times they imagine that being first implies a deeper purpose. Both reactions come from the same place: discomfort with open questions. The absence of earlier intelligence creates a large open question that does not have a straightforward answer. This openness can create a sense of unease because it removes the certainty people prefer. At the same time, the idea of being first can trigger curiosity rather than fear. Humans often explore the unfamiliar. They ask questions even when the answers are unclear. Being first means stepping into territory without maps. Some find this thrilling, others find it disorienting. But the emotional reaction itself reveals something important about human psychology. People want to understand their place in a story, and being first makes that story harder to define. Thinking about all of this highlights an underlying truth. The discomfort does not come from evidence or logic, but from how people process identity and meaning. Being first challenges assumptions about continuity, significance, and connection. It makes intelligence feel less like a shared feature of life and more like a rare spark. That rarity makes some people feel proud, others feel uneasy, and many feel both at the same time. When you look at it from a quiet, reflective angle, the feeling becomes part of the larger exploration. It helps explain why the search for ancient civilizations on Earth is compelling even when evidence is absent. The search is partly scientific but also deeply human. People want to know whether others came before them. They want to know whether intelligence is a repeating pattern or a singular event. They want to understand whether their own existence is part of a long chain or the beginning of something new. When you reach the point where you start to imagine what it would mean if humanity were not alone in Earth's past, the conversation shifts from evidence and probability to something broader and more reflective. It becomes less about proving or disproving the existence of earlier intelligent species, and more about understanding how such a possibility reshapes the way humans view themselves. All the earlier ideas about lost worlds, vanished coastlines, shifting continents, and temporary civilizations create a foundation for this final stretch of thought. They make space for a question that does not rely on confirmation. Instead, it invites consideration of what it would feel like to inhabit a world where intelligence might not have appeared only once. One of the first things that changes is the sense of uniqueness. Humans often grow up with the idea that their species represents a singular point in the history of life. They learn that intelligence, culture, and self-awareness belong only to humans. But if earlier intelligent species existed, even if they were different from us and long gone, that idea of being the singular peak fades. Instead, humans become part of a larger sequence. They become one expression of intelligence rather than the first or the only. That shift does not diminish human intelligence. Instead, it expands the context in which it is understood. Another idea that emerges from this possibility is the concept of shared experience across time. Even though earlier intelligent species would be separated from humans by millions of years, their existence would imply that the experience of thinking, wondering, solving problems, and navigating complex environments happened more than once. It would mean that consciousness was not a singular emergence but part of a broader pattern. That pattern could give humanity a sense of connection to a deeper history, not through direct interaction, but through the simple fact that other minds once lived on the same planet and faced challenges shaped by their own environments. Thinking in this way changes how people approach the long history of Earth. Instead of viewing the past as a linear build-up to humans, it becomes a series of chapters that include many species, many experiments, and possibly many forms of intelligence. This approach makes the planet's history feel more dynamic. It encourages a sense of curiosity about what kinds of worlds might have existed before humans arrived. It creates space for imagining how earlier intelligences navigated their landscapes, how they communicated, and how they organized their lives. Even without evidence, contemplating these possibilities adds richness to the way people perceive Earth's deep past. The idea also influences how humans think about survival. If earlier species reached intelligence and then vanished, it suggests that intelligence alone does not guarantee long-term endurance. It highlights the fragility of civilizations, not only in terms of physical survival, but also in terms of preservation. Earlier species might have developed culture, memory and identity, only for all of it to disappear without a trace. That disappearance does not mean their achievements had no value. It means that nature, climate, and time can erase even the most meaningful outcomes of a species' existence. This realization can create both caution and motivation. Caution, because it reminds humans that their own civilization is vulnerable. Motivation, because it encourages humanity to consider how to preserve knowledge, culture, and stability over long periods. If earlier species fail to survive, humans might want to understand why. They might want to avoid the same pitfalls. They might want to build systems that are more resilient, more adaptable, and more capable of navigating environmental challenges. Another change that comes from imagining earlier intelligences is the way people view evolution itself. In most modern discussions, evolution is presented as a process that produces complexity gradually. Humans are often viewed as its current high point. But if intelligence appeared more than once, it suggests that evolution may be capable of producing complex cognition under certain conditions. Intelligence would not be an endpoint. It would be one of several possible outcomes. This idea makes evolution feel less like a directed process and more like a set of opportunities that arise when environments favour certain traits. At the same time, this possibility reminds people that evolution does not preserve everything it creates. Many successful species disappear. Many traits that once worked become obsolete. If intelligence appeared earlier and vanished, it suggests that intelligence itself might not be as stable or sustainable as people assume. This can be unsettling because it challenges the idea that intelligence is inherently beneficial. It suggests that intelligence might require careful stewardship to avoid leading to collapse. Considering earlier intelligences also changes how humans think about communication. If earlier species had languages, symbols, or ways of transmitting knowledge, None of those systems survived. The thought that entire communication systems could vanish raises questions about how humans preserve their own. It encourages reflection on the kinds of information that lasts. Artifacts, writings, digital records, and physical structures each have different lifespans. If humans want their knowledge to endure, they might need to consider how to store it in ways that withstand geological time. Another part of the reflection concerns the variety of possible intelligences. Humans have a specific form of cognition shaped by their environment and evolutionary history. Earlier species might have thought differently. They might have perceived their surroundings in ways humans cannot imagine. Their intelligence might have focused on navigation, memory, cooperation, or sensory interpretation. They might have excelled in areas where humans do not. Thinking about this diversity broadens the definition of intelligence. It encourages people to recognize that intelligence is not a single trait, but a spectrum of capabilities shaped by context. This expanded view can affect how humans interpret modern non-human intelligence as well. It encourages curiosity about the cognitive abilities of other species. It draws attention to the ways animals communicate, solve problems, and coordinate behavior. It encourages people to notice intelligence in forms that differ from their own. If earlier species existed, they might have shared some traits with modern animals or developed completely unique ones. Either way, imagining the past makes the present feel more interconnected. The possibility of earlier intelligences also influences how humans view exploration. The traditional idea of exploration focuses on discovering new places or understanding ancient cultures. But thinking about earlier species shifts the focus toward uncovering lost histories that might never reveal themselves fully. It adds a sense of mystery to even the most familiar landscapes. A simple hillside, a buried valley, or a submerged coastline becomes a place where something significant might once have happened. This sense of hidden history does not require evidence to be meaningful. It simply acknowledges how much remains unknown. That sense of unknown can be calming rather than distressing when viewed through a sleep-oriented lens. It encourages people to accept that uncertainty is part of the world. Not everything can or must be known. Some questions invite contemplation rather than solution. Imagining earlier intelligences becomes a way of appreciating the planet's depth and complexity, not a challenge to scientific understanding. It becomes part of a broader reflection on how time smooths everything, how landscapes shift, and how stories fade. Another important aspect is how the idea shapes the perception of human responsibility. If earlier species existed and disappeared, humans inherit a world that might have hosted more than one intelligence. That inheritance carries weight. It suggests that humans have a role in maintaining the balance of the planet. It implies that intelligence comes with obligations, not just advantages. This thought does not need to be heavy. It can be gentle, reminding people that they are part of a larger sequence of life. It encourages care, attention, and perspective. The possibility of earlier intelligences also changes how humans think about discovery. If no evidence exists yet, it does not mean evidence is impossible to find. It means that discovery requires patience and subtlety. It means that answers might come from unlikely places. A fossilized imprint, a mineral pattern, or an unusual formation could one day reveal something unexpected. The chance of such a discovery may be small, but the possibility adds quiet excitement to scientific exploration. It encourages researchers to keep asking questions even when the answers seem distant. At the same time, imagining earlier species invites people to reflect on why they seek those answers. The search is not only about finding proof, it is also about understanding identity. People want to know where they stand in Earth's history. They want to know whether intelligence is rare, whether it has happened before, and whether it might happen again. The search becomes a way of connecting with the deep past, even if it produces no definitive results. This reflection ties back to the psychology discussed earlier. The idea of earlier intelligences satisfies the desire for continuity. It fills the empty spaces of the past with possibilities rather than silence. It softens the feeling of being alone in the planet's history. It gives people a sense of shared experience across periods they will never see. Even without evidence, the possibility has emotional resonance because it addresses questions about belonging, connection, and identity. Another part of this idea involves humility. Humans often view themselves as the species that finally reached intelligence. Imagining earlier species reminds people that their own position is temporary, just as earlier species, if they existed, eventually vanished. Humans may one day be replaced by another form of intelligence. This thought is not meant to be discouraging. Instead, it offers perspective. It encourages people to see themselves as part of a larger flow rather than the end point. It softens the idea of human exceptionalism and replaces it with a quiet awareness of continuity. It also changes the way people think about future evolution. If intelligence emerged more than once in the past, it might emerge again in the future, even if humans disappear. This idea adds a sense of ongoing possibility. It reinforces the view that intelligence is one of many outcomes of evolution, not a singular event. It suggests that the story of thinking beings on Earth might continue long after humans are gone. This possibility can feel comforting because it places intelligence within the planet's broader narrative rather than tying it solely to humanity. At the same time, the possibility encourages people to take care of their present. If earlier species vanished, humans might want to avoid repeating their fate. They might want to build systems that preserve knowledge, protect ecosystems, and support long-term stability. They might want to learn from the idea of disappearance itself, understanding that intelligence does not guarantee permanence. This thought encourages reflection rather than urgency. It helps people focus on the present moment, recognizing that their actions shape the future not only for themselves but for the planet as a whole. Thinking about earlier intelligences also has a way of bringing the vastness of Earth's timeline into personal perspective. People often think about history in terms of their own lifetimes or the stories they learned in school. When they extend their thoughts to millions of years, the scale becomes almost too large to grasp. Imagining earlier species provides an anchor in that vast timeline. It gives the deep past a sense of familiarity, even if the details remain unknown. It makes geological time feel less abstract, because it includes the possibility of minds that experience the world in ways that parallel human experience. Another effect of this idea involves curiosity about the future. If intelligence emerged in the past and emerged again with humans, then future eras might also host intelligent species. This view encourages long-term thinking. It makes the planet's future feel like an open possibility rather than a simple continuation of the present. It shifts the focus from what humans have achieved to what intelligence as a phenomenon might become in the long run. As you follow these reflections, they blend naturally with the idea that Earth's history contains far more possibilities than the evidence currently shows. The surface holds only fragments of the past. Most events, species, and behaviours vanished without a trace, whether earlier intelligent species existed or not. Thinking about them encourages a deeper appreciation for the complexity of Earth's story. It helps people recognise how much remains unknown and how much room there is for imagination, curiosity, and open-minded inquiry. And with that sense of openness, the thoughts move forward gently, leaving space for the idea that Earth's past, present, and future might hold more than humans can see.